What is up, ladies and gentlemen on YouTube? Buggy2988 coming at you once again live through the power of my fat greasy fingers. Today we're going to be doing some GCSE Maths grade 9 questions. By the way, if you are watching this video, thank you for downloading and buying my product. Hopefully you're not disappointed. If you are, then send an email here. You can send any death threats, I don't really care. Work out the formula for the nth term of the quadratic sequence. So here we have the sequence here. To find the quadratic nth term, first you need to find the difference between each of these terms. So that's minus 8, minus 2, plus 4, and then plus... that's not right. Wait, yeah. Plus 4 and then plus 10. And then each of these go up by plus 6. And that tells us that the quadratic sequence that we need to be concerned about is 6 divided by 2, which is 3. So we need to look at 3n squared. So first term is 3 times 1 is 3. 3 times 4 is 12. 3 times 9 is 27. 3 times 16 is 48, and then 3 times 25 is 75. Now we need to look at the difference between this and the nth term. So actually first we need the nth term here. So the nth term is 3 minus 5 minus 7 minus 3 and 7. So if we find the difference, we do the bottom subtract the top, because we're going to subtract this from this to get what's left over. We end up with 3 minus 3 is 0, minus 5 minus 12 is minus 17, minus 7 minus 27 is minus 34, minus 3 minus 48 is minus 51, minus 7 minus, plus 7 minus 75 is minus 68, and this is equal to minus 17n plus 17, because it starts at 0. So that's the linear sequence, because it jumps by 17 and it starts at 0. So we need to add this to this, and we should end up with the nth term. So the nth term is equal to 3n squared minus 17n plus 17. And that's our answer. So write that in at the bottom. So the next question: another bag contains 4 red balls, 5 green balls, and 6 blue balls. If 2 balls are drawn randomly without replacement, what is the probability that balls are a different colour? Both balls are a different colour. So we've got 2 balls drawn randomly without being replaced. What's the probability that they're a different colour? Now, there are multiple different ways of doing this, and as long as you get the same answer and you do something that makes logical sense, then you should get all the marks. But I'm going to do I'm going to do the probability of the balls being a different colour is equal to 1 minus the probability that the balls are the same colour. And what that's going to allow me to do is have a very nice, easy, simple calculation that I can do without needing a calculator, because this is a non-calculator paper. So the probability that the balls are the same colour, well, first let's start with the red ones. What's the probability that we get both balls red? So we get 4 over the total, which is 15, times 4 minus 1 is 3, 15 minus 1 is 14, because remember we're not replacing the balls. And then we're going to add on the probability that both are green, that's 5 over 15, times 4 over 14. 4 over 14. And then 6, so there's 6 blue balls, so the probability that both of them are blue is 6 over 15 times 5 over 14. 15 times 14 can be worked out if we do 10 by 14, which is 140, and then 5 by 14 is 70, so 140 add 70 is 210. So that's going to be 12 over 210 plus 20 over 210 plus 30 over 210, and then 10, so 12 add 20 add 30 is 62 over 210. That will get you all the marks because it's a non-calculator. We don't have to simplify that, but just in case you wanted to, that's 31 over 105. So once we've found the probability that they are the same colour is 31 over 105, the probability they are a different colour, which is what they asked for, is equal to 1 minus 31 over 105, which is going to be 74 over 105, and that is your answer. Find the exact solutions to the equation. This one's only 2 marks, so we're just going to use the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac. Now most people mess up with this bit of the calculation here, all over 2a. So 2a is 2 times 3. So this minus minus cancels out and it means a plus. So all of this is getting added to 49. So we get 4 times 3 is 12, times 8 is 96. 49 add 96 is 50 add 95, which is 145. So we end up with 7 plus or minus root 145 over 6. This one solved this equation here. Now it's the same as last time, only we've got the y squareds in the denominator. There's a couple of things that you can do here. You can use what's called a u substitution. However, what's a little bit quicker to do is just multiply everything by y squared. So if you do that, you get 6 plus 6y equals 5y squared. Now we can subtract all of them onto the right side, so we get 5y squared minus 6y minus 6 equals 0, and we still have to solve this for y, so we're just going to use the quadratic formula. Y equals minus b plus or minus the square root of b squared minus 4, a is 5, and then c is minus 6, all over 2c. So minus 4 and minus 6, those minuses cancel out to make a plus, so it's going to be 4 times 5, which is 20, times 6, which is 120. So we've got 120 plus 36, which is 156. So that's 6 plus or minus root 156 over 10. Now I think that 156 can probably be simplified, but don't worry about that because it's a non-calculator paper. Next question. This is algebraic fractions. We've got 3 different denominators, so unfortunately we are going to have to multiply the entire thing by all 3 denominators. Now don't worry, because we don't actually end up with a cubic at the end. We end up with a quadratic because each of the terms of the denominators cancels out with one of the brackets, so we only end up with 2 brackets. I'll show you what I mean. So we've got 3 lots of this cancels with this for the first part. So we get 3 lots of x minus 2, x plus 3. And then when you multiply the minus 2 over x minus 2, the x minus 2 cancels with that x minus 2. So we get minus 2, x minus 1, and then x plus 3. And then for the last one, the x plus 3 cancels with that one. So we end up with 1 lot of x minus 1, x plus 2. Oh, x minus 2. Well, the next step is just to multiply it all out. Now you'll notice that this is 3x squared minus 2x squared, which is just x squared, and there's an x squared on this side, so those will actually cancel out. So we just end up with 3x minus 4x, which is minus x, minus 18 plus 6 is minus 12, and then minus 3x plus 2 on that side, so we can plus the 3x over to the other side and we get 2x minus 12 equals 2. Add 12 to the other side and we get 14, 2x is 14, and therefore x equals 7. So that's our answer, x equals 7. Very long-winded question, but again, just getting you warmed up for the difficult questions to come. Remember, this is only the start of the paper, so it's not actually the difficult questions yet. Graph of y equals f of x is shown on the grid. On this grid, sketch the graph of y equals f of a half x minus 1 plus 1. Now, this is where a lot of people make a small error, and I'll show you the error. It's with which order your transformations take place. So the way that I like to look at it is, because this half is more powerful than the minus 1, the half takes effect later because it's more powerful. So it does the smaller stuff first, then the more powerful stuff later. So I'll show you what I mean. This y equals f of a half x minus 1 is the same as a half x minus 2 in brackets plus 1. Okay, they're the same because you can expand it out. So a lot of people translate this by 1, 1 when they actually need to translate it by 2, 1. Okay, so let's deal with the translation first. This minus 2, you might think it goes to the left, but because it's inside the bracket, it's going to do the opposite of what you thought. It's going to go to the right by 2. And then the plus 1 is going to bring it up 1. So the centre is going to be here rather than here at 0, 0. And then the half is going to stretch it outwards. So you'd think that the half would squish it because it gets smaller, but because it's inside the bracket, it does the opposite. It gets bigger by 2. So rather than the flat point here, or what's called a stationary point, being just 1 above and across, it's now 2 across and 1 above. So it's going to be here, and then likewise on the other side it's going to be here. So I'll try and draw this as best I can. Okay, my drawing might not be the best, but as long as you draw something that's got a similar shape and it passes through all those 3 points in the correct way, then you're on a winner. Write down the equation to translate f of x right by 2 and down by 1. This is just a simple translation. So right by 2, we're going to go inside the bracket because it's the x-axis we're dealing with. So we want to turn it right, so that's going to increase x by 2, but because it's inside the bracket, it's going to do the opposite, so we're going to do minus 2. And then down by 1, so we're going to subtract 1. Okay, so this is where the questions ramp up a little bit in difficulty. We're given a triangle below has an area of 84 centimeters squared. Find x. So we've got 3 sides. Well, 2 of the sides are given, and 1 of the sides we have to find. So this is quite a difficult question, actually. Probably the most difficult question that's towards the start of the paper, because it's one where you have to use your head to try and think about, okay, because I don't have a calculator, I can't just use angles. I can't just use half AB sine C because we don't know what C is. So instead, what I'm going to do is I'm going to split this triangle in half directly down the middle. And that way, we can get A and x minus A here. Okay, so A is just something that I've labelled. I've just labelled that as A, and we'll use A in a minute. And x minus A, because the whole thing is x, so we subtract A and we get this length here. Now, this is the height, I'll call it h, of the triangle, the vertical height. So obviously, to find the area, we're going to do half base times height, right? So we know the area is 84 centimeters. So for the first triangle here, this triangle on the left, we'll call this triangle 1. Let's use a few colours just to make it nicer. So this is triangle 1. For triangle 1, we've got area equals half AB sine, just a half base times height. Half base times height, which is going to be a half of A times H. And then for triangle 2, area is the same thing, half base times height, and we've got half base is x minus A, and then height is H again. So to find the area of the whole thing, we know it's 84, but in terms of algebra, we know it's half AH plus a half x minus A, lots of H, which equals 84. Now, if we expand this out, we get half AH plus a half XH minus a half AH equals 84. And you'll notice that that cancels with that. So we get 1 half XH equals 84. We can multiply by 2 to get XH equals, that's going to be 168. And so we know h is equal to 168 over x, and that's going to help us in a minute. So we know h is 156 over x. Sorry, 100 and 168, was it? 168 over x. Okay. Now that we know that, we also know that these, because I've drawn it directly down through the middle, this is going to be a right angle triangle. So we know that a times a squared plus h squared is going to be 13 squared. So let's do that. So h we now know is 168 over x, and because I don't know what 168 squared is, I'm just going to leave it like that. Now, we also know this is a right angle triangle, so we're going to use that. So we know x minus a squared plus h squared, which is 168 over x squared, equals 15 squared. Now, when I expand this out here, you'll notice something interesting happens. If you look at this part of the equation, it's the same as this equation down here, a squared plus 168 over x squared. So we can replace that with 13 squared, because we know that's equal to 13 squared. So x squared minus 2ah, sorry, that's meant to be ax, minus 2ax, plus 13 squared equals 15 squared. So we can subtract onto the other side 13 squared minus 15 squared. Now it helps to know your squares up to 15, so that's 225 minus 169. So that's going to be 31 plus 25 is 56. Now if we factorize out the x from the bracket, we get x lots of x minus 2a is equal to 56. So there's not really much more we can really do with this to find x and a. We know that a is something that we defined ourselves. Well, there probably is a mathematical way to work out the exact value of a, but using just GCSE methods, we get to this point and a lot of kids might be quite stuck not knowing what to do here. But if you think about it, this is just a number times another number equals 56. Well, what do we know makes 56? We know that 7 times 8 makes 56. We know that, well, we can times that by 2 and then divide that by 2, and that should also make 56. Now, if we times this by 2, we get 28, and then we divide this by 2, we get 2, so that should also make 56. But if x is 28, if these two are the same, then the triangle becomes impossible, because 28 along here is the same as 13 plus 15, so the triangle would actually just be a line, right? So it's not going to be the 28 one, or anything bigger. The 7 and the 8 one, well, that would be assuming that a is negative, because we have to do x plus something to get to 8. So we're not going to use that one, we're not going to use that one. So if we say x is 14, then to make this x minus 2a equal 4, a would have to be 5. Now, if we look at that, if we replace that with 5, and then 14 minus 5 is 9, h now equals 168 over 14, which is quite a difficult one to work out, but if you think that's just 140 plus 28, so that's going to be 12. H equals 12. A equals 5, and x minus a, or just x, equals 14. So to find the area of this triangle, it's going to be a half base times vertical height, which is a half, base is x, so it's a half x, which is 14, times vertical height, which is 12. So that's 6 times 14, which is 60 plus 24, which is 84, which is what we got up here. So the answer is x equals 14. Next question. A circle of radius 3 is centred at the origin and meets a circle of radius k centred at 512 at 2 distinct points. find the range of values for k. So with this one, it very much helps to have a diagram. So if we've got a circle centered at the origin, that looks something like this. That's a horrible circle. Try again. And the radius is 3. And it meets a circle of radius k centered at 512. So 512 is going to be somewhere up here. And the radius of this is k, but it meets it at 2 distinct points. So we know k has got to look something like this, meeting at 2 distinct points. So find the range of values for k. So if it meets at 2 distinct points, 512, this 512, let's first work that out. So we've got 5 along the bottom, 12 along the top. So to find the hypotenuse, we're going to use the Pythagoras' theorem. 5 squared plus 12 squared equals 25 plus 144, which equals 169, which equals 13 squared. So this is 13. So this length along here is going to be 13. And then obviously this is going to be 3 because the radius here is 3. And this is going to be 3. So the range of values for k, where the circle meets the smaller circle at 2 distinct points, is going to be 13 plus or minus 3. It's going to be within that range. So you get within the range of 10 to 16. So the range of values for k is 10 to 16. Given that k is 13, find the area of the triangle formed by joining the centres of the circle with radius k with the 2 points where the circle intersects the x-axis. So this, kind of hard to read what's going on, but find the area of the triangle formed. So if we think about our axes again, k is 13, so we know that our circle with radius k is actually 12 up, 5 along, and it's going to be 13 this way, and the radius is 13, so our circle is going to start here. Now, let's try and draw a decent enough circle, something like that. So the area of the triangle formed by joining the centres of the centre of the circle of radius k with the 2 points where the circle intersects the x-axis, well, that's these 2 points joined with this point here. So it's going to look like that's this point here joined with this point joined with the centre. So the triangle is going to be something like that. Okay? So we know the vertical height is 12. We know that we've got a base here. We can find the base because it's symmetrical. It's just 5 plus 5, which is 10. So the area is going to be half base times height, which is a half of 10 times 12. So that is going to be 5 times 12, which is 60. So the answer is the area is 60 square units. Okay, so next question. Given that y minus n over x equals x minus n over y, find the value of xy in terms of n when x is not equal to y and n is a positive integer. Okay, so we need to find xy. So first of all, I'm going to multiply the whole thing by xy just to get rid of the denominators here. So xy squared minus ny equals x squared y minus nx. So you might not know what to do here, but you'll notice these two terms here both contain xy as a factor. So we're going to get that onto one side. So we get xy squared minus x squared y, and then I'm going to put this onto the other side, equals ny minus nx, and that way we can factor out xy, and on the other side we can also factor out an n. And if you notice, we've factored out y minus x on both sides. So most of the time you wouldn't just cross this out, you wouldn't cancel these out, because you get you get values of 0, you're dividing by 0, but in this case it says x is not equal to y, and this basically means that y minus x cannot equal 0, because if y minus x equals 0, then y equals x, which cannot happen due to this rule up here. So we can just divide both sides by this, and so we get xy equals n. And then if you look at the original question, find the value of xy in terms of n, well, we've done it. Xy equals n. That's our answer. Next step, hence or otherwise, draw the graph of y minus n over x equals x minus n over I when n is positive. So this is a little bit of a trick question, only because it's not said that this condition here, x is not equal to y, is valid. So what a lot of people will do is they'll say, well, that is the same as that, which is incorrect, by the way, because remember we cancelled out the y equals x, because it said y is not equal to x, but in this case it doesn't say y is not equal to x, so we have to include that possibility in there as well. So first of all, when xy equals n, we can draw that graph as a reciprocal graph, because we know that y equals n over x. So that's going to look something like, let's see, something like that. And then on the other side, same thing, something like that. I'm not great at these. There you go, that's good enough. And then you also have to be concerned with y equals x. So if y equals x, then you end up with a line going through the middle like so. Something like that. Okay? So there's our graph of y minus n over x equals x minus n over y. If you don't get the x equals y line, then you subtract 1 mark off. But if you do, then you get both marks, obviously. Next question. Find square root of 13 minus 4 root 3 in the form x minus y root 3, where x and y are positive integers. So you're not explicitly told how to do this in GCSE maths. However, there is a way you can easily use GCSE mathematics techniques to actually calculate the values of x and y. And how you do that is you write it as an equality. Write it as an equation. And now to work out x and y, we're going to square both sides. So if you square both sides, you get x squared, so that's x squared, and then we're going to minus 2 root 3xy, and then you get plus 3y squared. Now, we're going to group the non-surds to one side, and the surds to another side. So we get that minus 2xy root 3. Now, because root 3 is irrational, we know that this minus 2xy is the same as minus 4, because we can never group the root 3 in with the rational numbers, okay? Those two kinds of numbers don't mix. So we know that minus 2xy equals minus 4. So we can divide by minus 2 and we get xy equals 2. Okay, so we know that y equals 2 over x. So now when we're dealing with the other side, what we can do with the full numbers is we can group those together. X squared plus 3, now y is 2 over x, so we'll sub in that, squared, equals 13. So x squared plus, this is going to make 12 over x squared, equals 13. Now I'm going to multiply everything by x squared, and you get a horrible, evil looking quartic equation, like that. Now we can subtract the 13x squared onto the other side, and there's two different ways of doing, well, there's really one different way of doing this kind of quartic equation. You'll notice it looks very, very similar to a quadratic equation, only instead of x to the 1 and 2, we've got x to the 2 and 4. X to the 4 is just x squared squared, and x squared, well, that's just x squared. So we've put those into brackets, and now you can see we've actually turned it into a quadratic equation. You've got your squared term, you've got your normal term, and then you've got your constant here. So it's actually a quadratic equation in disguise. So then what we do, you can either use factorization or the quadratic formula. I'm going to factorize it because it's one that can be factorized. So you get x squared minus 12 and x squared minus 1 equals 0. And that tells us that x squared is equal to 1 or x squared is equal to 12. Now, we need to find x and y. X and y are positive integers, so it's not going to be the negative values. So either x is 1 or x is root 12. Now, because we set this xy equal to 2, we know we're not going to pick this root 12 here. We could, but we're going to let x equal to a regular rational number just because it makes the numbers work out easier. So I'll show you what I mean. If you take x equals 1, then y equals 2 over 1, which equals 2. So x equals 1 and y equals 2. There is another set of numbers that you can have. So if x equals root 12, then y equals 2 over root 12. That also works. But the preferred answer is going to be this one here, because x and y are positive integers, not root 12. Okay, so x equals 1 and y equals 2. Right, this next one here, complete the square for x squared minus 4xy plus 3y squared equals 0. Then find x in terms of y. So this is quite a tricky problem if you're not familiar with complete the square. But with complete the square, you can actually do it with basically any term here. So this one, for example, we've got x minus 4xy. If we divide that by 2, we end up with minus 2xy. And if we get rid of the x, we just end up with minus 2y. So to complete the square, it's going to be x minus 2y squared. Then we're going to subtract the square of this, so that's 4y squared. And then we're going to have that plus 3y squared on the end equals 0. Now we can just simplify everything and move it onto one side. So we've got x minus 2y squared equals, and then this is minus y squared equals 0. And then add this over onto the other side. So we get x minus 2y squared equals y squared. And then we can get rid of the squares, like so. So we get x minus 2y equals y. And then the question asked us to find x in terms of y, so it's just x equals 3y. That's our answer. Question 10. The following shape is constructed by extending each edge of a regular hexagon. Find the exact fraction of the shape that is shaded. Now, there are multiple ways of doing this question. You can use the right angle triangles, and if you do that successfully and you get the same answer, then good, you get all the marks. But I'm going to do a grid because the grid's actually a little bit faster. So if you notice, this one here lines up with both of these sides, and this one lines up with this edge up here. And we know that because this is going to have rotational symmetry, and we also know that this is going to line up with this, and this is going to line up with this. So you can draw like a nice little grid here, which is 3 by 3. But before you start saying, oh, well, this is just 1/9, well, this edge here isn't the same length as this edge, okay? So we have to do a little bit more thinking than that. So find the exact fraction of the shape that is shaded. For example, let's take the length of the inside shape to be 1. Okay, this is going to help us to find this big length here. So if this is 1, then we know that this here is 1. Okay, because all the sides of a regular shape is going to be the same. So if we've got a triangle in here, this little white triangle, where you've got 1 on the hypotenuse, and we know this is 45 degrees, we can use our exact trig values to find the other two sides. That's going to be cos 45, and this is going to be, well, the other way around. This is going to be sine 45, and this is going to be cosine 45. And both of those is root 2 over 2. Okay? So if we think this is root 2 over 2, and this is going to be root 2 over 2, then this whole length along here, which is the same as this, is going to be 1 plus 2 lots of root 2 over 2, which is just 1 plus root 2. Okay, so this now we need to find this one here. This one's a little bit harder to find. If you think, well, this one here is a 45-degree triangle, so this is going to be the same, 1 plus root 2. So now the next step is, if we can find this length here, then we can work out what the size of this grid, or this box if you like, that outlines the entire octagon is compared to the size of this inner box that outlines the inner octagon. And that ratio is going to be the same as the ratio of the areas, because they're similar shapes, right? So this length is what we're trying to find. So we know that this is going to be 1 plus root 2 on this length here. So we need to do 1 plus root 2 sine 45 to find this length here. Well, this is going to be the cosine side. Well, it depends. If you take your 45 up here, then this will be the sine 45. So it's 1 plus root 2 times root 2 over 2. And that equals root 2 over 2 plus 1. So we know that is root 2 over 2 plus 1. This is going to be the same. So we've got 1 plus root 2 plus 2 lots of root 2 over 2 plus 1 is going to be the entire length of this large octagon, or the entire length of the large box. So that equals to 1 plus root 2 plus root 2 plus 2, which simplifies to 3 plus 2 lots of root 2. That is the length of this. Length of the bottom one is 1 plus root 2. So we need to find the exact fraction of the shape that is shaded. Well, that's going to be 1 plus root 2. So that's this bottom one. But it's the area we want, so it's squared, over the 3 plus 2 root 2 squared as well. So let's try and rationalise the denominator and see what we get. So this is going to be 1 plus root 2 over 3 plus 2 root 2. Now let's rationalise the denominator. 3 minus 2 root 2, 3 minus 2 root 2. Square both sides, or square the whole thing. So 3 on top, and then minus 3 root 2, minus 2 root 2, and then minus, so that's minus 2 times 2, which is minus 4, all over 9 minus, and then that's going to be 8. So, and that all is squared. So we get root 2 on the top, minus 1, over 1 all squared, which is just that. Root 2 minus 1 all squared. And that is equal to 2, and then minus 2 root 2 plus 1, which is equal to 3 minus 2 root 2. So the fraction of the shape that is shaded is actually 3 minus 2 root 2. A little bit of a weird fraction, but if you really want, you can do 3 minus 2 root 2 over 1. Okay, question 11. This one is, it's one where either you see it or you don't. Okay, you can stare at this for 10 minutes and waste all your time, or you can just look at it, think, I have no clue how to do that without a calculator, and move on to the next question and maybe try it later. This is one, you can do it without a calculator, but you need to know this trick. And the trick is, well, just look at this here and look at this here. What do you notice? They're basically the same thing, only instead of having a plus in front of this third, you've got a subtract sign. So what we can do is we can turn this into one single fraction, and we have to multiply this. So f of x equals 2x plus root 4x squared minus 10 into a bracket, and then we're going to multiply it by the denominator of this one, 4x squared minus 10, over 2x minus root 4x squared minus 10, and then we can add this plus 1 in the numerator on the end, because it's all part of the same fraction now. Now this is this is a difference of two squares, so we know that we've got 4x squared on the top, the inner and the outer cancel out, so then we just end up with minus 4x squared minus 10 on the top, plus 1 over 2x minus root 4x squared minus 10. So this cancels with this, and we end up with minus 10 plus 1, which is 11 over 2x minus root 4x squared minus 10. Okay, that makes it a little bit simpler, but we still have to work out f of 23. So to find f of 23, we are going to have to basically do 23 squared. So this is where you do 23, column method, 9, 6, 0, 6, 4, add them together, 9, 12, 5, 529, okay? And then if we multiply that by 4, multiply by 2, you get 1058, multiply it by 2 again, you get 2116, so that is 4x squared, and then subtract 10, you got 2106, so our answer is 11 over 2 lots of 23, which is 46, minus the square root of 2106, and that is f of 23. So we don't have to try and simplify that because it didn't ask for it. Just leave it like this. Next question. F of alpha over 11 equals 1 plus 3 over root 10. This one's kind of a difficult one. You have to recognise, well, we've just used this in the previous question. This is f of x. So f of alpha over 11 is just going to be 1 over 2 alpha minus root 4 alpha squared minus 10. And that equals 1 plus 3 over root 10. So what we can do with this is we can make it into one fraction, 3 plus root 10 over root 10. And then we can do the reciprocal of this to get 2 alpha minus root 4 alpha squared minus 10 equals root 10 over 3 plus root 10. Then we're going to rationalise the denominator, 3 minus 10, 3 minus root 10, and we end up with 9 minus 10 on the bottom, and then on the top we get 3 root 10 minus 10. So that is equal to, well, that's going to be minus 1 on the bottom, so that's going to swap this round, minus 3 root 10, and then you've got 2 alpha minus root 4 alpha squared minus 10. The last step, well, if you look at this this here, you've got 2 alpha and then you've got something in a root, and then if we say alpha is 5, just looking at the positive whole numbers, then look what happens on the inside of the bracket. We've got 4 lots of 5 squared, which is 100, minus 10, which is root 90, which is 3 root 10. So alpha is 5 works, okay? That's just, you're going to have to either see it or do some more algebraic manipulation, but honestly, again, just split up the surds and the numbers and you'll get a nice little integer answer. Next question. Factorise 6x squared plus x minus 1. So we've got to factorise this. So AC equals minus 6 using the AC method. I'm not going to explain how you do it, just going to go through the process. So you've got 6, we need to make minus 6 plus 1. So that's going to be plus 3 minus 2. So we're going to have a 3x. And then that's going to divide by 2, so that's going to be minus 1, and then we're going to have a 2x, and that's going to divide by 3, so that's going to be a plus 1 there. So that's 6x minus 2x plus 3x minus 1, which makes 6x squared plus 6 minus 1. So that is our answer. Okay, hence find the solutions to 6x squared plus x minus 1 equals 0. So it's just 3x minus 1, 2x plus 1 equals 0. And so we can say 3x minus 1 equals 0, and therefore x must equal 1 over 3. Or we can say 2x plus 1 equals 0, and x must then equal minus a half. So x equals minus 1/2 or 1/3. X is a positive integer, Explain why 6x squared plus x minus 1 can never be a prime number. This is one that has actually a very similar question has actually appeared on a past paper, and very few students got it right. So the reason why something like this can never be a prime number is because 6x squared plus x minus 1, as we worked out in the previous part of the question, is equal to 3x minus 1 times 2x plus 1. Now, if x is a positive integer, which is part of our answer, if x is a positive integer, then we know that 3x minus 1 cannot equal 1. So then we know 3x minus 1 is not equal to 1, because the first positive integer is 1. So if we start with the smallest, we've got 3 minus 1 is 2, so it's too big. Okay, and 2x plus 1 cannot equal 1 either, because again, start with 1, 2 lots of 1 is 2, 2 plus 2 is 3, so it's too big. So none of these, if x is a positive integer, none of these can equal 1. However, a prime number is only a product of 1 and itself. So there must be a 1 in in each of these terms. So, however, a prime number is only a product of 1 and itself. However, neither factor equals 1. Therefore, it cannot be prime. Question 13. A shaded circle is inscribed inside a rhombus such that each side of the rhombus is tangent to the circle. One of the angles of the rhombus is 60 degrees, as shown here. The length of each side of the rhombus is 2. Work out the exact fraction of the rhombus that is shaded. So this is another one, work out the fraction that's shaded. Now, the trick with this one is to look at the radius of the circle. Where we see the radius, we see it cross like here. So these are the two diameters. And then if we look here, we can cross. So if I draw these correctly, that shows how that crosses through the middle. So there's 3 different lines we can draw. These 3 lines will help us because we know this is tangent to the circle. So these are 90 degrees, these are 90 degrees, these are 90 degrees, and these are 90 degrees. We can also draw a line connecting the opposite corners of the parallelogram here. So we've got how many? 1, 2, 3, 4, 5, 6, 7, 8 right angle triangles here that we can work with. Now, we've got 60 degrees, but we know that this has just been bisected here, so we know this is 30 degrees. And we also know this along here connects the centre to the edge of the circle, so that's going to be the radius, r. And we've already got a nice right angle triangle here that has r on the height. The base is, well, the angle here is 30 degrees, but we don't know this length here just yet. But we can find this length here if we use a red triangle, so I'll call this the red triangle. Now, if we take a look at this area here, we know that this angle is 60 degrees. We know that we've got 2 coming out and 2 coming out. So we can actually split this in half into 2 equilateral triangles. And if we know this is equilateral, we know that this length here is 2. Then we know that this, because it's been bisected, is 1. So we know this length is 1. So we can use that to calculate, using this red right angle triangle, this length along here. So this is 1. And this is, I'll just do it in black. This is 1. And this is 2 on the hypotenuse. So 1 squared plus, and then we'll call this a squared equals 2 squared. So a squared equals 2 squared minus 1 squared, which is 4 minus 1, which is 3. So a is root 3, so we know this is root 3. And then we've got, all of a sudden, a nice triple here, a nice right angle triangle. We've got 30 degrees, we've got root 3 along the top, and we've got along the bottom 2. So what you can either do is you can either use, oh sorry, we don't have the 2 on the bottom. The 2 is stretching all the way along the bottom there. So We can use opposite and hypotenuse, so we're going to use sine 30 equals opposite r over hypotenuse root 3, and that will tell us the radius by multiplying both sides by root 3. Sine 30 is a half, so the radius is root 3 over 2. That's the radius of the circle. So we can use that by getting the area of the circle is pi r squared. So that's pi root 3 over 2 squared, which is 3 over 4 pi. So that's the area of this circle. And the area of the rhombus, well, we need to work out the area of the rhombus as well. So the area, it's made up of two equilateral triangles. So there's two on each side. So we're going to use half AB sine C, and that's going to times by 2. So we've got half 2 sine 60 times by 2, so we can cancel the 2 and the half. We get 4 sine 60, which is equal to 4 root 3 over 2, which is equal to 2 root 3. So we need to work out the exact fraction of the rhombus that is shaded. That's the inside over the outside, which is 3 pi over 4 divided by 2 root 3. So if we write that as a fraction, over 2 root 3. Now we need to get rid of this denominator here, so we'll multiply both sides by 4. That's 3 pi over 8 root 3. I'm running out of space here. And that cannot be simplified anymore, so that's 3 pi over 8 root 3. And that is our answer there. Next question. What is the value of 635 squared minus 35 squared? Again, this is one where either you see it or you don't. Okay, you can get the correct answer and you can get full marks by actually multiplying it out, multiplying what is 635 squared and what is 35 squared and then subtracting them from each other. You can award yourself full marks if you did that, but if you didn't, then there is a quicker way of doing it, which is the way that I intended for people to do it, which is the difference of two squares. This is a square and this is a square, so this can be represented as 635 plus 35 multiplied by 635 minus 35, which is 670 times 600. So we really only need to times, we really only need to do 67 times 6 and then multiply by 1,000 at the end, because we've just crossed off the 3 zeros. Add on the 3 zeros at the end, so that's 2, 42, 36 makes 0, 40. So that's 402 times 1,000, so our answer is 402,000. The curve x squared minus y squared equals 1 is reflected in the line y equals x plus 2. What is the equation of the reflected curve? This is quite a tricky one, but it's only, you can only really get it by if you're really good at graphs. First, let's think about this one here. X squared minus y squared equals 1. Well, y squared therefore will equal, well, if I add that onto that side and subtract that, x squared minus 1. So if we think about an x squared minus 1 graph, then that's something like this, where you get 1 here, minus 1 here, 1 here, and minus 1 here. Now, we're going to square root that graph, and what happens is when you square root this, it turns that way, but also we've got to take into the plus or minus as well. So it's going to go like that, and it's also going to go like that, and now square roots of negative numbers don't exist, so that's just going to be blank in between. So the graph of x squared minus y squared equals 1 actually looks like this, and you can try it on Desmos if you want. It does genuinely look like that, and you can just work that out just by using, you know, a little bit of common sense, a little bit of logic, and now it's reflected in the line, not y equals x, but y equals x plus 2. That's what makes this question a little bit difficult. We know this is 1, sorry, this is minus 1, and this is 1, so y equals x plus 2 is going to go through like that. So when we reflect it in that line, we're going to have something that looks like this on this way around, and then this way around it's going to look like that, because you'll notice that that's the same distance apart from the graph each way around, and that is actually the same graph, only the x and the y are flipped round. So that's because when you rotate by y equals x, or any y equals x plus c, you just flip the x and the y around and then you translate the graph, okay? That's with any y equals x plus c when you rotate through that line. There are more complicated ways of rotating through the line, and if you did that, you can get full marks for it, but obviously using just GCSE methods, you'll have to basically draw the graph, draw a diagram, see what happens to the graph when you reflect it through that line, and then try to create this graph using what you already know from this equation. So we know that we want to translate the x direction up to here and the y direction up to here. But what is this point here? Well, this point here is going to be intersecting with that point and that point. So it's actually going to be up by 2, because this is going to be 1, this is going to be minus 1, 1, and it's going to be in line with the minus 1. So this point is actually minus 1, 2, and that's going to be the centre of our new graph. So we've got to think about, okay, how do we find the centre of this new graph? Well, the centre is actually reflected. So if we look at the centre here, when 0, 0 is reflected, 0, 0 is reflected in y equals x plus 2, that's, that line crosses through 1, minus 1, 1. So to get to the other side, it's going to go another minus 1 and then up another 1, so it's going to end up at minus 2, 2. And that is going to be our new centre. So the centre of this graph, this new graph, is minus 2, 2, and the equation is going to be the same as this equation, only with the x and the y flipped round. So let's do the first thing. Let's flip round the x and the y, and we get that. Now, if we want to translate the x by 2, we want to translate the x left 2, so this is going to be plus 2 on the inside of the x-axis, on the inside of the x bracket, just like any function of x, so we're going to get plus 2 on the inside. And then we also want to move the y up by 2, but remember, when you put it inside the bracket, it actually does the opposite of what you expect, so we need to make it a minus, like that. And that is the answer to our question, okay? Y minus 2 squared minus x plus 2 all squared equals 1. The final question, question 15, the radius of the circle is 1. Find the shaded regions in terms of theta and pi. Again, you need to think about this, well, you need to think about this not in terms of what you've been taught before, because you won't have been taught this before, but you need to think about it intuitively. It asks for the shaded area in terms of theta and pi. It's not important, therefore, about what this angle here is, or this angle here. It doesn't matter about what the angles that each of these lines make with a tangent. So, we know that if this goes up like this is going to be the same. Just by the way the question is worded, it's in terms of theta and pi, so we know that theta is the only thing that matters. It's not given us any other angle value here, like alpha or beta or whatever. It's just given us theta. So what I'm going to do to simplify this down is, instead of drawing the diagram like this, okay, the trick with this question is I've basically drawn the diagram quite difficult for you, but I can make it easier for myself by drawing the diagram such that the theta lines up completely with the tangent like this. And because we know that this angle doesn't matter because it's not in the question, then this area should be the same as this area here. Okay, and it turns out that it is. Alright, so we'll work that out. This is a radius of 1. So this is just a sector. So let's draw our radii here and here. So to work out the area of the segment, we do the area of the sector, subtract the area of the triangle, will give us the area of the sector, the segment. So that is, well, we need to use circle theorem. So if this is 90 degrees along here, this is theta 90 minus theta. So 90 minus theta on the other side, so this angle is 180 minus 90 minus theta times 2, which equals 2 theta. So this is 2 theta, okay? So that's 2 theta on the bottom. Then we've got a radius and a radius. Now we know the radius is 1, so we'll just replace that with 1. So the area of this sector is going to be 2 theta over 360 degrees times pi r squared. R is 1, so it's just 1 squared, minus the triangle, which is going to be, so that's 2 theta, that's 1, so that's going to be half AB sine C, 1 squared sine 2 theta, which equals, so let's think, that cancels out, that cancels out, so we end up with theta over 180 pi minus a half sine 2 theta. Okay? And the answer says find the shaded area in terms of pi and theta. Well, we've got pi's and theta, and we haven't got any other variable. So the shaded area is just pi over 180 minus half sine 2 theta. Okay, and that's the answer to that question. Next paper, paper 2. The Great Pyramids of Egypt are geometrically similar, square-based pyramids. The volume of Pyramid 1 is 240 meters cubed, and the volume of Pyramid 2 is 810 meters cubed. The surface area of Pyramid 2 is 675 meters squared. Work out the surface area of Pyramid 1. Now, you should know, as part of your GCSE knowledge, that the scale factors actually square and cube when we're dealing with volumes. So when we're dealing with volumes, we know that the 240 times by our scale factor cubed is what gets us to our 810. Because they're geometrically similar, there's a scale factor. So the ratio cubed is equal to 810 over 240, which is 81 over 24, which is, let's think, divide that by 3, that's 27 over 8. Now we can cube root that to get 3 over 2. So that's our ratio. The surface area of Pyramid 2 is 675, so we want to find out the surface area of Pyramid 1. And that multiplied by r squared is 675. R squared is 3 over 2 squared, which is 9 over 4. So if we divide this by 9, we get, divide this by 9, that's going to be, how many 75s is it? 1, 2, 3, so that's 8, yep, so it's 75. And then multiply by 4, we get the area equals, so double it again, you get 300 meters squared. Okay, and that is our answer, 300 meters squared. ABCDA is a rectangle, ADEA and AEFA are both right-angled triangles, angle AEF equals A degrees, angle FEC equals AFB equals B degrees, AE equals 1, prove that sine A plus B equals sine A cos B plus cos A sine B. So, using our unit triangle, okay, something that you need to know is that if the hypotenuse is 1, and if this is theta, then this is sine theta, and this is cosine theta. Okay? And using that same principle, we can work out using this triangle here that's diagonal, this right angle triangle here. We know that EF, so let's write this down because it's a proof. EF is equal to cos A, and we know FA is going to equal sine A, And we know, so this is sine A, so we know that FB is going to equal sine A cos B. Okay, and then this side here, using the EFC triangle, we know this should actually have a right angle here. Does it say EFC as a right angle? E F A E and ADEA. Okay, yeah, so this is a right angle triangle here, so we know ECF, CF is going to be so this is EF, which is cos A, so CF is going to be cos A sine B. Now we also know that AD is going to be, because using AED right angle triangle, we also know that AD is going to be sine A plus B, so AD equals sine A plus B in brackets, and BC is equal to BF plus FC. And BF, as we've worked out, is FB, which is sine A cos B, plus FC, as we worked out, is cos A sine B. Now, because this is a rectangle, as it says up here, A, B, C, D, A is a rectangle, then we know that AD equals BC, AD equals BC, therefore sine A plus B equals sine A cos B plus cos A sine B. Okay, and that is how we got our proof. Very, very long-winded. I understand if you run out of space. If you do run out of space on that question, then just use extra paper because it is quite a cramped area to do that whole proof in. Hence, find the exact value of sine 15 degrees. So to find sine 15 degrees, we use what we already know. We already know sine 60, and we already know sine 45. So I'm going to use those. But this exact equation here, A plus B, is adding them together. So we need to actually find sine of minus 45. So if we use the sine graph, then we know that if sine of 45 marks with here, which is root 2 over 2, minus sine of 45 is going to be minus root 2 over 2. We know that because it's like it's almost symmetrical, but it's negative. So it's minus root 2 over 2. So sine of 60 plus minus 45 equals, using our proof, sine A, so sine 60, cos B minus 45, plus cos A 60 times sine B minus 45. Now we also need to know cos of minus 45. Cos is actually symmetrical, okay? So cos of minus 45 is cos of 45, which is root 2 over 2. So this is going to be root 3 over 2 times root 2 over 2 plus 1 over 2 times minus root 2 over 2. So this is root 6 over 4 minus root 2 over 4. So our answer is root 6 minus root 2 over 4. Prove the alternate segment theorem. This is one of those things that you are meant to have been taught in your lessons, but everyone kind of forgets because it's kind of it's just like a long thing to remember, so I thought I'd throw it in here. Prove the alternate segment theorem. The alternate segment theorem is basically, in this diagram, x equals y. We have to use this O here, so if we draw a line, AO, That's not in line. If we draw a line AO and a line OC, then you can see here that this is a radius, so this will make a 90-degree angle with the tangent. So let's write that down. So OC E, so that's angle OCE equals 90 degrees, and the reason is DCE is a tangent to a circle. Therefore, we know that OCA, which is this little angle here, is going to be 90 minus OCE. So we know that's going to be 90 minus y. Sorry, 90 minus ACE, which is 90 minus y. So we know OCA is 90 minus y. Now we also know that this is a radius here, and this is a radius here. So we know that this is an isosceles triangle. So OAC is an isosceles triangle. OA equals OC, which equals the radius. So that's how we know that it's an isosceles triangle. And that tells us that OAC is equal to OCA, which is equal to 90 minus y degrees. So we can work out, using angles in a triangle add to 180, the angle of the angle of AOC, and we know OAC and OCA is both 90 minus y, so that's angle AOC plus 2 lots of 90 minus y equals 180. So we can rearrange that, so that's AOC plus 180 minus 2y equals 180. Those cancel out, so we know angle AOC equals 2y, and that therefore angle so AOC equals 2y, that's enough. Now by using the angle, so we know this is 2y. Now this is subtended by the arc AC, and angle ABC is also subtended by the arc AC, but this is at the circumference, this is at the centre, and we know that the angle at the circumference subtended by the same arc is half the angle at the centre. So we're going to use that to prove that ABC must equal a half of AOC equals a half of 2y, which equals y. So angle ABC also equals x, therefore x equals y. That proves the alternate segment theorem. Next question. Mr. Beast measures the attention span of TikTok users by timing the number of seconds x before the user swipes to another video. The results are plotted in a histogram below. Oh, something has gone a bit funny with my histogram. Okay, so given that 0t to 10, so basically this here, from 0 to 10, has a population of 70. Fill in the values of the table. So I'm going to use the frequency density along the side, but you'll notice that the numbers are actually not put on. So I'll just put my own numbers on, because it doesn't actually matter what numbers you put on. Well, it kind of does. But in terms of proportion, it doesn't. So this we'll call 2.4. It might be 4.8, it might be 6.0, we don't know. But we'll call this 3, 4, and 5. So this will be 4.6. So we know if we take 2.4 times 5 plus 4.6 times 5, that is equal to whatever our frequency density scale factor is, lots of 70. Well, it's actually 70 over our frequency density scale factor, but we'll leave it like that, okay? So that's 2.4 times 5 gives us 12, and then 4.6 times 5 is 23. D70, and that is 35. So in this case, D is actually 2. So we've actually done it, basically this needs to multiply by 2, okay? So our frequency density is actually 2, 4, 6, 8, and 10. Okay, and now we can work out the frequency of each table by just finding the area. So the frequency of each row is just 5 times 4.6, which is 23. And then, oh wait, actually no, not 4.6. 5 times, so I'll just cross that off. It's 5 times, so that's going to be 9.2, which is 46. And then it's going to be 5 times 2.4 times 2, sorry, that's not 2.4. 5 times 4.8 this time, which is 24. 5 times 4.8. Oh yes, so 10 times 4.8, which is 48, because the class width is 10. And then 15 times 2.4, which is 36. And then 30 times 0.8, which is 24. And just to check if that adds up to... oh, it's not giving us a total. Never mind, we don't get a total, so we're just going to have to go with that. And fill in the values of the table. We've done that now. Hence, estimate the number of people with an attention span less than 20 seconds. So we've got to estimate the number of people that are to the left of this line. This should say seconds on the bottom, shouldn't it? Okay, so to estimate the number of people with the attention span less than 20, we just use the graph. So this first box is going to be 5 times 2.4, which is 12. So I'll put in 12 in there. Then we've got 10 times 4.8, which is 48. And then we've got 5 times 9.2, which is 46. 46 plus 48 plus 12 should be our estimate, so that gives us 106. Okay, question 5. Find the shortest distance between the point A equals 1 minus 2 and the line y equals 1 minus 1/3 x. So to do this, we basically need to find the shortest line that connects this line to this point. Okay, and how we find that? Well, if we imagine a circle that's growing, as the circle grows, it doesn't currently have the straight line in it yet. And that means that the distance away from the point is not yet great enough to meet the straight line. But as soon as the circle touches the straight line, that's when we know that that distance there, the radius of the circle, is the shortest distance possible to get to the line. Because this radius here, if we try and connect to the line any other way around it, it'll make it longer than the radius. Does that make sense? So if I try to connect, if we imagine a circle like this that's tangent to the line, if I try to connect the point to the line like this, that's longer than the radius. If I try to connect a point to the line this way, that's longer than the radius, right? But if I connect it directly to the radius, then that is the shortest possible distance, is the radius of that circle. So we just need to find the radius of that circle. And how we do that is we use a circle theorem. This is a tangent to the line, tangent to the circle, so the line is going to make an angle of 90 degrees with the radius. That means that this line here is perpendicular to this line here. So we'll call this L1 and we'll call this L2. So we need to first find this point here where L1 meets L2, but we first need to find L2. So the gradient of L2 is going to be the negative reciprocal of L1. We know this is L1 up here because it tells us L1. So the negative reciprocal of that gradient equals 3. So that's m of L2. Now we're going to use y minus y1, which in this case is minus 2, equals m bracket x minus x1, which in this case is 1, to find our equation for the line. Y plus 2 equals 3x minus 3. So y equals 3x minus 5. That's L2. So we need to find where L2 crosses L1 to find this point here. So L2 is 1 minus 1/3 x equals 3x minus 5. And where those two cross, so let's multiply everything by 3. And then let's add x onto that side. And then add 15. So we can say x equals 9 over 5, or 1.8. And that's the x coordinate of this point here. So to find the y coordinate, we'll use the original equation here. So y is going to be 1 minus 1/3 9 over 5, which is 1 minus 3 over 5, which is going to be 2 over 5. So we know that this point here, let's call it B, is equal to 9 over 5, 2 over 5. And so we just need to find r, which is the distance between A and B. So the distance between A and B is the square root of 9 over 5 minus 1 squared plus 2 over 5 minus minus 2 squared. That's equal to 4 over 5 squared plus that's equal to 4 over 5 squared plus 12 over 5 squared, which is the square root of 16 plus 144, which is root 160 over 25. Now we can take out a 10, so we can do root 16 over 25, and these are both square numbers. Take out our root 10, so we end up with 4 root 10 over 5. Question 6. Using algebra, show that root 2 plus root 2 plus root 2 plus root 2 plus ... equals 2. So this ... is meant to symbolize going off to infinity, just like in, I guess, recurring decimals. And just like in recurring decimals, we can use algebra to work out the exact value of this. So if we say x equals root 2 plus root 2 plus root 2 plus ... and we keep going, then what happens is when we square x, we get rid of the big square root on the outside, and we end up with this. But because this goes off to infinity, this is equal to this. These two are equal. So this is just 2 plus x. So we can subtract this onto one side, and we get x squared minus x minus 2 equals 0. So we can factorize this into x minus 2 and x plus 1, which tells us that x equals minus 1 or 2. And if you look at this up here, there's no plus minus symbol above here, so we're just going to take the positive value and say that x equals 2, and x also equals that, therefore we've proven the original statement. ABCDA is a parallelogram. AB equals A, DA equals B, and BY equals KA. M and N are the midpoints of D and C, DC and BC respectively. X is the midpoint where AC intersects MN. DX and XY are collinear. Work out the value of X. So collinear means that they fall on the same straight line. So that's what that means. And we need to work out the value of K. So to work out the value of K, we're going to use, basically we're going to have to find dx first. Then we're going to have to find dy, and then prove that we can show that dy, because dy and dx are collinear, how we can basically find what the value of k is. So let's do that. So to find dx, first we're going to do dA. So, dx equals dA, which is b, plus ax. Now ax, we're just going to call it Actually, we'll call it P lots of AC. And P is our scalar parameter, because we don't know how far along the line X is, so we'll leave it like that. Now, to find AC, AC is going to be A minus B, because this is a parallelogram, so we know that this is also B, and this is also A. So AC is A minus B, so let's put that in. Okay, so we can also use, we can also find dx by going through m, so let's do that. So dx is dm, which is a half a, plus some other scalar parameter of mn. So to find mn, well, m and n are both midpoints, so it's going to be half of a plus a half of b. Okay. So now what we can do with these two is we can compare how many vector A's we have on the left hand side and how many vector B's we have on the right hand side. So let's do the vector A's first. So we've got P equals, and then we've got a half A, and then we've got a plus a half QA here. So we've dealt with the A's, and now we've got vector B's. So we've got 1 minus P equals, and then we've got a half B on the right hand side. Sorry, a half Q on the right hand side. So now what we can do is we can sub in this here, so let's do that. So 1 minus P, which is a half, plus a half Q, equals a half Q. So that's going to be a half minus a half Q equals a half Q. So we can add on 1/2 Q to both sides, and we get Q. So we get Q is a half. Okay. Now we know 1 minus P is a half of Q. So 1 minus P is a half of a half, which is a quarter. So we know P must be 3/4. So we've got both our scalar parameters. P is 3/4, Q is 1/4, and that allows us to basically use either of these to work out what dx is. So let's ignore the P one, let's use the Q one. Q is a half. So we can use that to find dx, which is plus a half of a half A plus a half B. So you get a half of a half A makes a quarter, so let's group that together with the first half A. We get 3/4 A, plus a half of a half B is a quarter B. So we've found dx. Now it tells us dx and xy are collinear, and that means that dx equals r lots of xy. So we're using another scalar parameter here. So because they're collinear, dx must equal some multiple of dy, or xy, sorry. So we need to find xy. So let's do that. Xy is equal to, well, we can go to xa. So xa. Now xa is actually q lots of AC, isn't it? Sorry, it's q lots of CA, because we know q is, sorry, it's p lots of CA, because we know we've used PAC equals AX, and we found that P equals 3/4 using these equations here. So so we know that XA is equal to 3/4 lots of CA. But then we've also got to add on A and then KA as well. Okay. Now CA is minus AC, which is B minus A, so that's 3/4 B minus 3/4 A plus KA, and that is equal to, so if you multiply by R, then that is equal to dx, so 3/4 a plus 1/4 b is equal to r lots of 3 over 4b minus 3 over 4a plus ka. So let's group this together. R lots of 3 over 4b, and then you've got plus 1/4 a, so that's plus 1/4 plus ka, so we've just factorised the a out of this whole expression here, and that is equal to this on the left hand side. So compare the a's. 3 over 4 is equal to r lots of 1 over 4 plus k, and compare the b's. 1 over 4 equals r lots of 3 over 4. So we can easily see here that this tells us r is 1/3, and that means that 3/4, so this tells us that r is 1/3. That means 3/4 equals 1/3 of 1/4 plus k, which is 1/12 plus 1/3 k. Subtract a 12th from this, so this is 9/12. So subtract a 12th, you get 8/12, which is actually 2/3. So we've subtracted a 12. 2/3 is 1/3 k, so we've found that k must equal 2. Next question. Below is a diagram of a cylinder inside of a sphere. The sphere has a radius of 17. The volume of the sphere is V. Find V in terms of h. So we've just got to find the volume of the sphere in terms of h. So we're going to use Pythagoras' theorem. Because we know this is the radius is 17, and we know that this is going to be half the height, we can use Pythagoras' theorem to work out the radius in terms of h. So let's do that. So if this is 17, this is h over 2, and this is the radius of the cylinder, just like in this diagram here, then we know r squared plus h over 2 squared equals 17 squared. Now we've got to find the volume. The volume V is the volume of the cylinder, which is pi r squared h. Now we know that r squared is going to be 17 squared minus h over 2 squared. So we need to find V in terms of h, so we might as well plug that in. V equals pi h r squared, which is 17 squared, minus h over 2 all squared. So this question will be easy if you're good at basically keeping everything nice and collected and put together so that you don't have to expand out the 17 squared. So pi h r squared, which is that. So we've basically found V in terms of h, but if you wanted, what we can do is we can do pi h, and then we can factorize this into h over 2 and 17 plus h over 2. Okay, and that is our answer. Given that h is 5, find the value of V. Pi lots of 5, 17 plus 5 over 2, 17 minus 5 over 2. So 17 plus 5 over 2 is going to be 34 over 2 plus 5 over 2. So that's 5 pi lots of 39 over 2 times 29 over 2, which is, so let's do that. 29 times 39, that's 1131 over 4, and then times that by 5, so we'll get 5500 plus 155, which will give us 5655 over 4 pi. 5655 over 4 pi. Okay, nearly run out of space there. 5655 over 4 Again, get the same answer with a different equation. Bob's your uncle. The frame of the wind, or maybe it's Harry, or maybe it's Barry, or maybe it's Larry, I don't know. Who's your uncle? Drop it in the comments. Oh, it's not a YouTube video. Anyway, the frame of a circular wind chime is a circular metal ring. The frame of a wind chime is a circular metal ring with 3 strings attached at equal distances apart on the ring. Each string is attached to the same point vertically above the centre of the circular ring on the other end. The length of each string is 20 centimetres and the angle between adjacent strings is 40 degrees as shown below. Calculate the circumference of the metal ring. Give your answer to 2 significant figures. Okay, so below is a diagram containing 3 regular hexagons. Each smaller hexagon is constructed by joining the midpoint of each side of the large hexagon. The length of each side of the large hexagon is 1. What fraction of the large hexagon is shaded? Okay. So whenever you see these triangles here, you've got these isosceles triangles, always split them into right angle triangles, and it's usually because right angle triangles are way more useful. So if this is the midpoint here, this length here is going to be 1/2, and we know that the internal angles of a hexagon is 120 degrees, so we know this is going to be 60 degrees, okay? So we've already got a right angle triangle that we can use to work out this length here, so let's do that. So this is 60 degrees, and this is 1/2, so we're going to work out this adjacent side here, so cosine 60 equals adjacent over hypotenuse, which is 1/2. So adjacent equals 1/2 cosine 60, which is 1/2 of 1/2, which is 1/4. So now we know that this length here is 1/4. Now I'm going to split this up into equilateral triangles, because a hexagon, to work out the area of a hexagon, you have to split it up into equilateral triangles. Okay? But one little shortcut that I'm going to use, just because this would take a long time if we were going to do it the long way and work out the area of the shaded bit and then work out the area of the white bit. Just to make it a little bit quicker, we're going to use the fact that this is just repeated 6 times. You see this shape here, this triangle here. This is just repeated 6 times. Okay, it's repeated here, 1, 2, 3, 4, 5, 6. It's just repeated 6 times. So what we're going to do to work out the fraction of this whole thing that's shaded is just work out the fraction of this that's shaded. So really, all we've got to worry about is an equilateral triangle like that, where, so let's take this one for example, where you've got 60 degrees. These are going to be 3/4. These are going to be 3/4, and the whole thing is going to be 1 all the way along, because we know that these are 1 here. So the whole thing is 1, so that's 1, 1, 1, and then on the inside we've got 3/4. So we've just got to work out the area of this 3/4 triangle divided by the area of the triangle with with side length 1. So that's going to be half AB sine C, so the area is half AB sine C. So for the small triangle, that's going to be half 3/4 squared sine C, which is 60 degrees, which is 1/2 9/16. Sine 60 is √3/2, which is 9√3/64. And then the area of the large triangle is going to be half AB sine C again, which is going to be 1/2. AB is going to be 1 squared sine C, which is 60 degrees. 1 squared is just 1, so it's going to be 1/2 √3/2, which is √3/4. So we need to work out the the fraction. So we need to turn this into a fraction by doing 9√3/64 divided by √3/4. The √3's cancel on both sides, and we can multiply both sides by 4, so that would make this cancel here, and then if we multiply this by 4 we get 9/16. So our answer is 9/16. You do get 9/16/1, but obviously the 1 doesn't count, so we get 9/16. That's our fraction of the hexagon that is shaded. Again, if you worked out the area of the entire hexagon and then put it over the area of the big hexagon and you got the right answer anyway, give yourself full marks, but that's the quickest way to do it. The diagram shows a circle on a Cartesian plane. Okay, A is on the y-axis, B is on the x-axis, and the line AB is tangent to the circle. OBA is 30 degrees. The shortest distance between the circle and B is 8. Find the coordinates of A. So we just got to find these coordinates here. And we're told that this is 8. Okay, that's it. So this is the radius of the circle. This is also the radius of the circle. That's also the radius of the circle, but we don't need to use that because this here is a right angle triangle because that is a tangent which makes a 90-degree angle with the radius. So we can use that. Now we need to work out A. So we just basically need to find this here. So we'll say this is... Okay, we'll call this H. Alright, because as soon as we find H, then we found the point A. This is a right angle here. Once we find R... then we can find, let's see. We know this is 60 degrees, so we know this is 30 degrees. So once we find R, then we can find H. Okay? We know this is 60 degrees because this is 30 degrees. Now using this right angle triangle here, so let's draw this out. We've got 30 degrees here. We've got on the adjacent side an unknown value. Okay, so let's leave the adjacent side out. We've got the opposite side is r, and the hypotenuse is r plus 8. Okay, that's the hypotenuse is r plus 8. So we can use opposite and hypotenuse. Sine 30 equals opposite over hypotenuse. So a half equals r over r plus 8. So we can say, let's times it by 2, so 1 equals 2r over r plus 8, so r plus 8 equals 2r, so 8 equals r, okay, because we just subtracted r from both sides, 8 equals r. So we know the radius is 8, so we know that's 8. So now let's use the second right angle triangle here. We've got an angle of 30 degrees. We've got the adjacent side is the radius, which is 8. We've got a opposite side we don't know, and a hypotenuse is h. And as soon as we find h, we've got the y-coordinate of A. We know A is where it intercepts the x-axis, where it intercepts the y-axis. So we know x is 0 at the point A. So we'll just leave it at this. And then we've got an adjacent side and a hypotenuse, so we're going to use cosine. 30 degrees equals adjacent over hypotenuse. So hypotenuse equals 8 over cosine 30 degrees, which is root 3 over 2. So our h is 16 over root 3, because we can keep flip change for that fraction. And we need to find the coordinates of A. So as a coordinate, the x-coordinate is 0, and the y-coordinate is 16 over root 3. So next question. X plus y to root xy is 5 to 2. X is greater than y. Find the ratio x to y. This one's quite a difficult one. You have to know how to use fractions to solve ratio problems. So if x plus y to x to root xy is equal to a ratio that we know, then we can write these as fractions, one over the other. Okay, and then we can multiply by 2 root xy, so we get 2x plus 2y equals 5. So sorry, 5 root xy. That's correct. So we've got 2x minus 5 root xy plus 2y equals 0. We need to find the ratio x to y, so it would help us to know xy or x in terms of y. Now, this is kind of difficult to see, but you can actually complete the square in this case, because this is root x squared minus 5 root y root x plus 2 root y squared. So if we write it like that, then we can complete the square. So let's divide by 2 first of all. So we've got got 5 root x squared minus 5 over 2 root y root x plus root y squared equals 0. At this point here, we can use the quadratic formula, okay? That will be a little bit quicker than completing the square, so let's do that. Root x is equal to minus b, which is 5 over 2 root y, plus or minus the square root of b squared, which is 25 over 4y, minus 4ac, which is 4y, all over 2 lots of a, which is 1. So we get 5 over 4 root y plus or minus, and then this here, I'm going to take out the root y, so we get root 25 minus 4, 25 over 4 minus 4 over 2 root y. So let's simplify this here. 5 over 4 root y, so this is 25 over 4 minus 16 over 4, which is root 9 over 4, which is 3 over 2, so plus or minus 3 over 2 root y, which is of course 5 over 4 root y plus or minus 3 over 4 root y. Now if we factor out the root y, we can get 5 over 4 plus or minus 3 over 4 lots of root y equals root x. Now the question tells us that x is greater than y, so this tells us that root x must be greater than root y. So using that fact, if we go with the negative, we'll get root x equals a half root y, which would mean that root x is smaller than root y, which isn't correct. So we're going to go with the positive value. So we're going to say 5 plus 3 is 8 over 4, so that's going to be 2 root y. Now the question was find the ratio x to y, so we're going to square both sides. So we get x equals 4y. Now to find x to y, we can use the same method that we used right at the beginning and turn it into a fraction. So we get x over y equals 4 over 1. So x to y is 4 to 1. X to y is 4 to 1. And that is our answer. Okay, so next part, given that y to z is 3 to 5 and x is 6p, find z in terms of p. So we know that x to y is 4 to 1, so let's find x to y to z. So 4 to 1, and y to z is 3 to 5. Times that by 3, then you get 12 to 3. So this is 12 to 3 to 5. So we know x is 6p. We need to find z in terms of p. So that's going to be, so that's divided by 2, so that's going to be 5 over 2p. So our answer is 5 over 2p. Question 13. Cans are loaded onto a truck in the arrangement shown below. Ignoring the edges of the truck, calculate the percentage of the volume of the truck filled by the cans. Give your answer to 3 significant figures. This is one of those ones where maths actually applies to real life. Only this is quite a difficult question because you have to, again, be very good at geometry and understand ignoring the edges of the truck. How we're going to do that is we're not going to look at the edges, we're going to look at this inside bit here. Now we need to calculate the percentage of the volume of the truck filled by the cans. This is the cross section, which is actually quite useful because cans are just cylinders, right? They're just circular prisms, which means that if we find the percentage of the area of these circles that is covered, sorry, the percentage of the area that is shaded in these circles, then we can find the percentage of the volume that is taken up by the cans in the truck. So it applies quite nicely, and how we do that is if you look at the centres of the circles here, connect these up. So let's connect up the centres of the circles. You'll notice they all make triangles, and the triangles do something called tessellating. You do tessellating earlier on in school, but I don't think it's part of your GCSEs. However, tessellating, what it does when it tessellates is the inside here, these three sort of circular shapes, they repeat as well. So really, this pattern here is just a whole load of repeating tessellations of the same exact circle pattern. And that pattern, if we just find out the percentage of that pattern that is shaded, then we've worked out the percentage of the whole thing that is shaded. Then we've worked out the percentage of the volume of the truck that is filled by cans. Okay, so this is an equilateral triangle, okay, because they all tessellate and they all have the same side lengths. Each equilateral triangle contains 3 arcs, like so, where each of these is R. So all we have to do is work out the percentage of this triangle that is shaded. And how we do that? Well, let's work out the area of the whole triangle. That's a half AB sine C. It's an equilateral triangle, so C is 60, so A is 2R, B is 2R, sine 60 degrees. So we've got half of 4R squared, which is 2R squared. Sine 60 degrees is root 3 over 2. So we end up, that cancels with that, with root 3R squared. That's the area of the triangle. And now for the area of the circles, well, you could do it all separately to get the area of 3 separate segments. Sorry, 3 separate sectors. However, what I like to do is I like to group these all into one sector, because we know this is 60 degrees. We know that's R. We know we've got another one, 60 degrees, and we know that's also R, and we know that we've got a third one, 60 degrees, and that's also R. So we can just do area is equal to 3 lots of the same exact sector, which is going to be 60 over 360 times pi r squared. Also, you can do it as a semicircle, because 360s add to 180, which of course makes a straight line, which makes a semicircle. So 3 lots of 6 over 36, that's 1/6, so that's going to be a half. And then pi r squared, that's going to be our area for the 3 sectors. So all we need to do is work out the percentage of the volume of the truck filled by the cans. So that's going to be half pi r squared, which is the volume filled by these circles here, and then divide that by root 3 r squared. The r squareds cancel out, so we end up with a half pi over root 3, and then just to make the fraction into like one nice big fraction rather than having a fraction within a fraction, we're going to multiply both sides by 2, so we get pi over 2 root 3. You can also rationalise the denominator, so you get root 3 pi over 6. It says give your answer to 3 significant figures. It asks for a percentage. So that is a fraction. To get a percentage, you just type it into your calculator and you should get 90.7%. Snigglefritz Wobblebottom has 3 sources of income: a business selling pants to help people with IBS, selling woodworkings on eBay, working as a school teacher. So these are all named X, Y, and Z. In January, Snigglefritz Wobblebottom earned £1,460 in total. In February, X, which is his business selling pants, earned 50% more, Y earned 20% more, and Z earned 20% less than in January. He earned £1,472 in total in February. In March, X earned 50% more, Y earned 50% less, and Z earned 5% less than in February. He earned $1,696 in total in March. Calculate how much money each of X, Y, and Z earned in January. Solutions relying on calculator technology will not be awarded marks. That means that if you have some of these simultaneous equation solvers in your calculator and you just bash the numbers in, you will not be given any marks for this. But there is a way to do it without a calculator, and this is quite a painful question. So let's first start off with January. We've got his 3 sources of income. We'll just call them X, Y, and Z, and that gives him £1,460. In February, X earned 50% more, so that's going to be 1.5x. Y earned 20% more, so that's going to be 1.2y. Z earned 20% less, so that's going to be 0.8z. And he earned total of 1,472. In March, X earned another 50% more, but remember that's more than in February, so that's that times 1.5, which is 2.25x. And then Y earned 50% less, so that's 0.6y. And then Z earned 5% less, so that's going to be 0.76z. And that's earned him a total of 1696. Calculate how much money XYZ earned in January. So all we need to work out is what is X, Y, Z. What are each of these values? So first of all, I've noticed these two are quite closely related to each other. So I'm going to multiply M by 2. So we get 2 times the earnings in March. That's going to be 4.5x plus 1.2y plus 1.4, what's that going to be, 1.52. Now we can subtract this 2m from f, so 2m minus f, and we get 3x, so the y's cancel, and then we get plus 0.72z equals, using your calculator, 1920. And then that gives us an equation for x and z. Now what I'm going to do is I'm going to try and find another way to cancel out y's and make another equation for x and z using different pairs of equations. And what I can see here is if I multiply this by 1.2, then I can use it to subtract from this and then get the y's to cancel again. So I'm going to do 1.2 lots of January, 1.2x, plus 1.2y plus 1.2z equals 1460 times 1.2. So use your calculator. You should get 1752. And now we can subtract February from 1.2 January. So February minus 1.2 January, and you get 0.3x, y's cancel, and then we get minus 0.4z. And then on this side, we end up with minus 280. Okay, so now we have two equations for x and z. Let's multiply this by 10, so we get 3x minus 4z equals minus 2,800. That's going to help us to pair it with this one here. So we've got x and z's in both of these. Now we're going to subtract, because there's 3x and we can cancel the x's, so we're going to subtract this one from this one, and we get 4.72z equals, and then subtract that using your calculator is 4,720. Now you don't even need your calculator to see that that means z is 1,000. So that's our first value found. Z was his business working as a school teacher, so that's 1,000. Now we know Z, we can work out X very easily using this equation here. So 3x minus 4,000 equals minus 2,800. So 3x must equal 1,200. So X must equal 400. So there's X found. And then finally we need an equation for X and Y, so we might as well use this top one here. X is 400, Y we don't know, Z is 1,000, and so that makes 1,460. Cancel off the 1,400, and we should see that Y equals 60. So we found all three values, 400, 60 and 1000. Question 15. An equilateral triangle OAB with sides of length 6 has a straight line going directly through the centre, meeting the triangle at 2 points x and y. Construct the equilateral triangle. So what you would do is you'd place your compass here, and then you construct an arc like that, and then you'd place your compass here, and you construct an arc, oh that's a horrible arc, construct an arc like that, and then you would take a ruler and you would connect the arc like so. And that would be your equilateral triangle. Obviously I haven't used an actual compass, so this is this is a little bit off. But that is how you get those marks there. Now next is find the shortest possible area of the triangle OXY. So it says here you've got OAB, so this is OAB, and we've got a line going directly through the centre, meeting the triangle at 2 points X and Y. So if we imagine it like this, we've got an equilateral triangle with a line going through the centre, meeting at X and Y. And we've got to find the smallest possible area, so that should say smallest, possible area of OXY, which is this area here. So there are really two possibilities, okay? There's the possibility that OXY goes vertically through the triangle, like this, or the line goes parallel to the side AB, and that would look something like this. So the reason why I'm not checking any other possibility is because you've either got through like that, through like this, or you've got somewhere in between. But the reason I'm not checking somewhere in between is because we know that we need to find the smallest possible area, and just by using common sense, it's unlikely that it's going to be some random point in between. If you're thinking like, oh well, what about this direction? Well, that's just the same as this, only rotated. So any other direction, the same with this one, that's just the same as this, only rotated. So any other direction that you can possibly imagine, like this, that's just a random line. But if we did like this, for example, well, that's just that rotated. So we're not going to check that, okay? We're just going to check these two possibilities. So we need to find the area of the smaller triangle. So this one here, it's quite easy to see that this is just half the area of the large triangle. And to find the area of the large triangle, well, we know the length is 6, so the area of the large triangle is half AB sine C. We want to half that, so we get a quarter AB, which is 6 squared, sine C, which is sine 60 degrees. So we get 36 over 4, which is 9. Sine 60 degrees is root 3 over 2. So we end up with 9 root 3 over 2. Alternatively, with this one is a little bit trickier to find the area. We know that it's parallel here, so we know that these are both equilateral triangles. So to find OXY, we just need to find, again, half AB sine C. But the problem then becomes, well, what is A and what is B? If I draw a triangle like this, and I split it up along the centres, like so. If I draw a triangle like this, and then I draw a cross, such that the cross goes through the centres like so, and then I draw lines across like here, then you'll see that this here is just the exact same as this. Okay, because this is parallel to this line, and it crosses through the centre, so that's the same. So if this whole length here is 6, then these two is going to be 4. Same with this side, these two is going to be 4. So we're really dealing with half AB, which is 4 squared, sine 60 degrees, which is 8 sine 60 degrees, which is 8 root 3 over 2, which is 4 root 3. So the question is, which is smaller, 9 over 2 root 3 or 4 root 3? And if we ignore the root 3, because that's the same on both sides, then we can see that the 4 is going to be smaller than 9 over 2. So our answer is the smallest possible area of OXY is 4 root 3. Okay, that's the end of paper 2. Let's move on to paper 3. Here is a set of 4 numbers. When the 2ax term is removed from the set, the mean reduces by 1. Find A in terms of x, leave your answer as a surd. So we need to find A in terms of x. When 2ax is removed, the mean reduces by 1. So that tells us that the mean of this, which is 3x, x minus 3, plus 2, 1 minus 5x, plus a squared, plus 2ax over 4, equals, so that reduces by 1 when you remove the 2ax term. So you get 3x minus 3 plus 2, 1 minus 5x plus a squared over 3. Okay? Now we can multiply by 12 to make it one big long equation. So 4x. So we end up with 9x, x minus 3, plus 6, 1 minus 5x, plus 12ax, plus 3ax, 3a squared, plus 6ax, minus 12, equals 4x, it's going to be 12x, x minus 3, plus 8, 1 minus 5x, plus a squared. So you can quite quickly make out this is just going to be a problem where you have to just do a lot of algebra and hope that you get it right and you don't make a mistake. So let's group it all onto one side. So let's first start with the a squared. So we need to find a in terms of x. So what I'm going to do is I'm going to focus on grouping it in terms of a. So we've got 2a squared. So we've dealt with those two. Then any a terms, yeah, we've got 6ax plus 6ax. Any more a terms? Don't see any. And then the non-a terms is going to be, well, 9x squared, but we're subtracting 12x squared, so we've got minus 3x squared. I've just realised I forgot to multiply this by 4, so that's going to make this minus a squared. Again, you're probably going to end up making a lot of mistakes in this one. So we get a squared minus 6ax plus 3x squared minus 19x plus 14 equals 0. So we need to find a in terms of x, so we're going to use the quadratic formula again. But this time we're not using x as our subject, we're using a. So a equals minus b, which is 6x, plus or minus the square root of b squared, which is 36x squared, minus 4ac minus 4. A is 1, c is 3x squared minus 19x plus 14, all over 2a, which is 2 lots of 1, and you should end up with 6x plus or minus, and that's all over 2. So interestingly enough, yes, you can divide this by 4, all of these by 4, and that's good because we've got a 2 on the outside. So when you divide this by 4, you get a root 4 on the outside, which makes a 2. So we end up with a equals 3x plus or minus square root of, well, it's going to be 4 on the outside. Root 4, that divides by 2, so it cancels. So you get 6x squared plus 19x minus 14. Okay, and that is our answer. So a equals 3x plus or minus root 6x squared plus 19x minus 14. I should have mentioned at the start that the paper 3 questions are very rotten. Question 2. The length of the hypotenuse of a right-angled triangle is 466. The length of the other two sides are both integers. Using algebra, find whether a and b are odd or even. Okay, so this one, it kind of gives you a hint as to how you do it. I mean, it's odd or even, so we know we're using 2n minus 1 or 2n. So let's start with a is odd. Okay, so let's first assume a is odd and b is odd. So we're going to say a equals 2n minus 1, b equals 2m minus 1. So 2n minus 1 squared plus 2m minus 1 squared is equal to 466. So that's 4n squared. 4n squared minus 4n plus 1 plus 4m squared minus 4m plus 1, which equals 466. Subtract 2 from both sides, you get 4n squared minus 4n plus 4m squared minus 4m equals 464. Now, is this divisible by 4? Well, if you half it and half it again, you are able to half it and half it again. So, dividing both sides by 4, n squared plus m squared minus m equals, so you get 116. Okay? Now, those are all integers, so that all checks out. But let's say if b is even, so we'll say b is 2m. Let's see what happens. 2n minus 1 squared plus 2m squared equals 466. So we have already expanded that out, so just copy it from above. 4n plus 1 plus 4m squared equals 466. So we'll subtract 1 from both sides. 4n squared minus 4n plus 4m equals 465. And here's where the trick comes in. The trick is this cannot be divisible by 4 because look, if I divide both by 4, I get 465 over 4 because it's not divisible. But n and m should both be integers. So we'll say reject because m and n are integers. Okay, so that's the key bit that you need to put in. And then same with if both are even. So if a is even, and so a is 2n, and b is even, then b is 2m. So we get 2n squared plus 2m squared equals 466. So we get 4n squared plus 4m squared equals 466. But that is not an integer because you get n squared plus m squared equals 233 over 2, which is not an integer. So m and n are integers. So you cannot possibly get a fraction from integers. So that's where the trick comes in. And then if a is even and b is odd, it's the same result as when a is odd and b is even. So you don't need to write that out again because it's the same result, only the letters are flipped. So this proves that a is odd and b is odd. Okay, so the answer is therefore a and b are both odd. You don't need to find a and b, so we're okay there. Question 3. The diagram shows a solid cone and a solid cuboid. The cone has a diameter of w and a slant height of l. The cuboid has a width of w and a length of w and a height of l. The surface area of the cone is equal to the surface area of the cuboid. So their surface areas are equal. Find an expression for w in terms of pi and l. Okay. So to find an expression, well, let's first worry about surface areas. So surface area of a cone is pi r squared on the bottom, so you've got pi w over 2 squared, and then we've got the curved surface area, which is the diameter pi w, sorry, the circumference pi w times l over 2. Now for the surface area of the cuboid, well, we've got w squared plus, so we've got 2 lots of that, and then we've got another 2 lots of w squared, and then we've got 4 lots of wl, because the wl's are around the sides here, so that's 4 lots of wl. So let's multiply this all by 4 because we get w squared over 4 times pi plus pi wl over 2 plus 2w squared plus 4wl. So if we multiply it all by 4, we get pi w squared plus 2 pi wl equals 8 w squared plus 16wl. Now what do we need to find? W in terms of pi and L. So we've got pi, W's and L. So this is the equation that we need to use. We just need to simplify it as much as we possibly can. So let's first factorize out pi and W because that appears twice in this one. So we've got W plus 2L equals, and then we've got, actually, we need to find W in terms of pi and L, so it's probably best if we factorize out the W's. So let's subtract it all onto one side. So we've got pi minus 8 W squared, because I've subtracted the 8W squared. And then we've got plus 2 pi minus 16 WL. Alright, good. So we've got that equal to 0. So we know we can factor out a W. Now, this will give us a solution of W equals 0 and another different solution as well. So I'll show you what you get. So this will give you this solution here. Now the alternative, so this will give you this here once you factorize it. So either W equals 0 or this equals 0. Because we're dealing with geometry, we know that we can't have a width of 0, otherwise the shapes wouldn't exist. So we're going to ignore that, and we're going to focus on this solution here. So this lots of W plus this lots of L equals 0. We need to find W in terms of pi and L, so we're going to use pi minus 8W equals, and then we're going to subtract this, so we get 16 minus 2 pi L on the other side. And then we're going to divide by pi over 8, so we get 16 minus 2 pi over pi minus 8 on the bottom, L, and that is equal to W. So that is our final answer. 16 W equals 16 minus 2 pi over pi minus 8 L. Okay, so relatively easy question when you compare it to the other ones. ABC MYDA is a square, Y is the midpoint of DC, X is the point where AM intersects BD, Y is the point on DC such that XY is perpendicular to DC. Using vectors, show that dy to ym to mc is 2 to 1 to 3. Okay, so with this question, we're going to call this A and we're calling this B. So using vectors, we need to show that dy to ym to mc equals 2 to 1 to 3. So first I'm going to find ax, okay? Because x is the point that will help us get to xy, which will help us get this whole thing on the bottom. So find ax. So there are two different ways of getting to ax. Well, there's plenty of ways to get to ax, but there's a scalar parameter lots of am, because it's part of am. And so let's do that. So p lots of am, which is a plus a half b. Okay, because we're going down a and then a half b. Okay, and it's also equal to ab. So if we go this way, and then we go q lots of bd. So it's ab, which is b plus q lots of BD, which is B plus q lots of A minus B. Okay, so now we can equate these two by comparing coefficients. So P is equal to, how many have got, we've just got QA here, so P is equal to Q. And then for the B's, we've got half P is equal to 1 minus Q. Okay, so that means a half P is equal to 1 minus P. So that means 3 over 2p is equal to 1. So that means p is equal to 2 over 3. And that means that q, because q is equal to p, is also equal to 2 over 3. Okay, so now we know where x is, okay? That'll be useful because we can work out xy, which will help us get dy and ym. And then mc is half b, we already know mc. So let's work out xy. So xy, let's see where we're going to go. xy, let's go here. I'm going to try and use as much space as possible here. xy is, if we go up here, xa, and then down, and then across, so we go xa, which is, well, we worked out p and q, so p is 2/3, so we know that xa is 2/3 of ma, so 2/3 of ma, and then we're going to go a, which is ad, and then we're going to go to y, so that's going to be a scalar parameter, so we'll pick r, so plus r lots of, and then r lots of b, because that's d to c. Okay, so we're aiming to find r, so 2/3 of ma, well we know am is that, so ma is just going to be the negative of that, so it's going to be minus 2/3 a minus 1/3 b, and then we've got plus a plus rb. Okay, now we need to find xy another way, so let's go through this way around this time. So xy, so that's going to be equal to, well, xb is, have we done xb? Yes, we have. So xb is, so that's 2/3 of bd, because we know that q is 2/3, and we've used that scalar parameter for that line before. So we know we've got xb, which is 2/3 of db, 2/3 of db, and then b to c, which is just a, and then c to y, which is going to be some scalar parameter, so pqr, suppose we can use s, some scalar parameter s, lots of cd, which is minus b, so that's going to be a minus, and that's going to be a b. Okay, honestly, absolutely horrifying is this, but eventually you do get to an answer. So db is, what is db? db is minus a plus b, so it's 2/3 b minus 2/3 a plus a, so that's going to be plus 1/3 a plus 1/3 a minus sb. Okay, and that is equal to that up there, so let's compare the a terms we've got. So that's going to be 1/3 a equals to 1/3 a again. Oh, that's not helpful. And then for the b terms, we've got minus 1/3 b plus r. Let's ignore the a's. So minus 1/3 plus r equals 2/3 minus s. So notice we've been trying to find it using xy, but there's a reason why these equations aren't working, okay? And this is part of the trick why, because if we look at xy, that's parallel to a. There's not going to be any b components, so we can set the b's equal to 0. And just using this part, we can see s equals 2/3. Okay, so that tells us that yc is 2/3 of b. So that basically gives us everything we need to know. As soon as we find s is 2/3, then we know dy. So dy is 1. Let's do it down here. if we've got enough room, dy is going to be 1 minus s lots of b, because we've defined sb as being like that. So 1 minus s lots of b is dy, which is 1/3 b, okay? And we know mc is equal to a half b. And we know that ym must equal the bit left over. So ym must equal, let's do it down here, ym must equal 1b minus 1/3 b minus 1/2 b, which is 1/6 b. So really, the ratio dy ym mc, dy to ym to mc, is the ratio 1/3 b to 1/6 b to 1/2 b, which, if you cancel out all the b's and multiply by 6, is the ratio 2 to 1 to 3. Magnus Carlsen is playing 2 rounds of chess in a chess grandmaster tournament. There are 3 possibilities in each round. He could win, draw, or lose. The probability Magnus has a draw is 0.1. The probability of each win, draw, or loss remains the same for both rounds. The probability that the outcome of the first round is different to the outcome of the second round is 0.58. The probability of Magnus winning is greater than the probability of Magnus losing. Calculate the ratio of Magnus's wins to draws to losses. Okay, so it's helpful to draw yourself a tree diagram here. It tells us that the probability that he draws each round is 0.1, and the probability of each win, draw, or loss remains the same for both rounds. But we need to work out the probability of Magnus's wins and his losses. Now, it tells us that the probability that the outcome of the first round is different to the outcome of the second round is 0.58. So that is equal to 1 minus the probability that the outcome of the first round is the same as the outcome of the second round, because the probability of not being the case is equal to 1 minus the probability. So we know that the probability that they have the same outcome, we'll just do probability of the same, is 0.42. Now that is the probability of wins plus the probability of draws plus the probability of losses being the same, which equals 0.42. Now we know that the probability of draws is 0.1, so we know that that's 0.1 squared plus losses squared is 0.42. So we can subtract this, which is 0.01. So you get w squared plus l squared equals 0.42. Now we also know that wins plus draws plus losses equals 1, because the branches of each of these must equal 1. So, and we know that draws is 0.1, so wins plus losses equals 0.9. Now we can use these 2 equations to work out the ratio of W to L. What we can do is we can replace the L with 0.9 minus W, and then put that into this equation up here. So we get W squared plus 0.9 minus W squared equals 0.41. That's meant to be 0.41. Okay. So that's W squared plus 0.81 minus 1.8 W plus W squared equals 0.41. So now if we collect like terms, then we've got 2W squared minus 1.8W. So we've dealt with those and those. So now we've just got to subtract that, and then we get plus 0.4 equals 0. Now we can multiply each of these by 5 to get 9W plus, and then this is going to turn into 2 equals 0. So AC equals 20, so we can use 5W and 2W. So that's going to be minus 5 minus 4, which is minus 2, and then that's going to divide by 5, so it's going to be minus minus 1 equals 0. So 5w, so we get two solutions basically. W equals 2 over 5 and W equals 1 over 2, or W equals 0.4 or 0.5. Now it says at the beginning the probability of Magnus winning is greater than the probability of Magnus losing. So W is greater than L. That means we're going to take the greater value, which is 0.5. So the ratio of Magnus's wins to draws to losses would be 0.5. We know his losses are 0.1, and so his losses are going to be 0.9 minus 0.5, which is 0.4. And so that's 5 to 1 to 4. So that is our answer. Question 6. X squared equals y minus 2 lots of x plus y. Find x in terms of y. This is a quadratic equation. So let's multiply. Question 6. X squared equals y minus 2 lots of x plus y. Find x in terms of y. This is a quadratic equation, so we can subtract it onto the other side. So x squared minus y minus 2 lots of x plus y equals 0. So x equals minus b, which is y minus 2, plus or minus the square root of b squared minus 4ac all over 2a. So that's y minus 2 plus or minus the square root of 4y squared, y squared minus 4y plus 4 minus 4y all over 2. That's supposed to be a minus, that's why I'm getting it wrong. That's a minus, which makes that a minus. That's a plus, so those cancel there. And this makes a minus 4. Question 7. The diagram below shows a cup being filled with water. The cup is made from a frustum and a cylinder of radius 3.5 centimeters and height h centimeters. The base of the frustum has radius 3 centimeters and the top has a radius 3.5 centimeters. The height of the frustum is 10 centimeters. So that's basically everything's written on the diagram already. The cup is being filled at a constant rate. After 2 seconds, the height of the water in the cup is 6 centimeters. After 5 seconds, the cup is full. Work out the value of h. Give your answer as a fraction in its simplest form. Okay, so we need to work out the value of h using these basically. So after 2 seconds, the height of the water in the cup is 6 centimeters. So we can easily work out if the height is 6 centimeters, that's going to be 6/10 of the way to 3.5. So that's going to be, so that's 6, that's 4. So that's going to be 3.3 centimeters radius up here. That's just using ratios. So if you see, this is 6 centimeters, this is going to be 4 centimeters. Therefore, that's going to be, so if you divide it into 2 centimeter sections, you've got 3.1, 3.2, 3.3, 3.4, 3.5 radius up here. So this is going to be the 3.3 radius. Okay. So the radius is 3.3. The height is 6 centimeters. So how we find the volume of a frustum is we have to take the volume of the cone and then subtract the volume of the smaller cone. So we're going to have 2 cones. Now the base of this bottom cone is 3.3. So that's the big cone. And the height, now we need to work out the height. So if we start with the smaller cone's got a base of 3 centimeters, because that's the base of the smaller cone. And the height, if we think about it, this goes down by 0.5 after 10 centimeters. So to get it down to 0, which is at the very tippy top of the cone, we need to go another 6 more. So that's 6 times 10 centimeters. So the height is 60 centimeters. That's the vertical height. So for this one, the vertical height is going to be 66 centimeters, because it's 6 centimeters more. So we need to do pi r squared h over 3, which is the volume of the cone, for this one, and then subtract pi r squared h for the second one. So we get, let's just do that now. Pi r squared, which is 3.3 squared h, which is 66 over 3. So pi r squared h over 3, and then subtract pi r squared, which is 3 squared 60 is the height over 3. And using your calculator, 2,979 over 50 pi. So that is the first volume, and that is after 2 seconds. Alright. After 5 seconds, the cup is full. So let's do the second one. So the second one is another frustum. This time, the larger cone is 3.5 centimeters. The smaller cone is still the same size. It's 3 centimeters by 60. This time, the height of the larger cone is 70 centimeters. So we've got pi 3.5 squared times height 70 over 3 minus pi 3 squared times 60 over 3, which equals, so let's, if you use your calculator, which is equal to 635 over 6 pi. Now we need to add on the the volume of the cylinder, which is 3.5, so pi r squared h, which is 3.5 squared pi times the height, which is h. So plus 635 over 6 pi equal 49. So that's going to equal 49 over 4h plus 635 over 6, all lots of pi. Now I'm going to have to use some extra space on the bottom here. That is the volume of the full cup. So now we know the area of the full cup, and we know, the volume of the full cup, and we know the volume after 2 seconds. So this is going to be 2/5 of this, because this is after 2 seconds, this is after 5 seconds. So this is 2/5 of this. So 2979 over 50 pi is 2/5 of 49 over 4h plus 635 over 6 pi. Now we can ignore the pi's off both sides because they are constants, and we can expand this out. So now we can expand that out, and then we can subtract that onto the other side. You should get 49 over h is that, so we need to work out the value of h as a fraction. H equals 2587 over 735. Okay, question 8. S equals 2u over u plus t squared. Now, with this one, you have to think about your limits, because we need to find the minimum value of s. To get s to be minimum, we need the 2u to be minimum and the u plus t squared to be maximum. Okay? However, the question then becomes, well, we need the u to be maximum up here, but we need the u to be minimum up here. So which way do we go? Well, this is why this question is 4 marks, because you try it both ways. We know we need t to be maximum, so t equals 100. Okay, done. T is 100. We need to find the minimum size of s, so first we try u equals 5. S equals 2 lots of 5 over 5 plus t squared, which is 100 squared. So you get 10 over 10,005. Okay, and now we try u equals 15. S equals 2 lots of 15 over 15 plus 100 squared, which is 30 over 10,015. Now, which is smaller out of these? You can use a calculator and get decimal values, which will show you that this one is smaller. So the answer is 10 over 10,005. Now, watch out, because it does say give your answer to 4 significant figures. So you don't actually want to give it as a fraction. You want to give it as a decimal, which is 9.995. That looks like a 6. 9.995 times 10 to the minus 4. Next question. Given that u equals t and it's not equal to 0, write t in terms of s. Okay, so u is t. We need t and s, so let's just replace all the u's with t. So s equals, and then what's it, 2t over t plus t squared. And we need to get t in terms of s. So we multiply both sides by t plus t squared. St plus st squared equals 2t st squared plus 2st minus 2t equals 0. We can factor out a t, so we get st plus s minus 2 equals 0. We need to get t in terms of s, so we know t is not equal to 0, so we can divide that. St plus s minus 2 equals 0. Now we only have one t, so that's perfect. We just make that the subject. So we get st equals 2 minus s. So t equals 2 minus s over s. T equals 2 minus s over s. Perfect. Okay, below is a grey semicircle inscribed inside of a quarter circle of a radius 2 inches. Find the perimeter of the grey semicircle. Okay, so for this one, we have a semicircle inside of a quarter circle. You have to think about where the circle meets and where the radii are, okay? Because there's many radii we've got to deal with. There's two circles with two different radii. We know the radii of the large one, the radius. So what I'm going to do is I'm going to draw a radius connecting here. We know that's 2 inches. And we know that that is 2 inches. Okay? Now, radii of the small circle, we know this, and we know this is equal to the radii of the small circle. Okay? So we know that this, by Pythagorean theorem, because this is the radius, we know this is going to equal radius root 2. Okay? So we've got that radius. Now we know this is a right angle here. Okay? And we know that this up here is a radius, because it follows from the centre to the edge. So if we draw that right angle triangle along here, then we've got the base r root 2, we've got the height r, and we've got this is 2 inches. So now we can solve this. R squared plus root 2r squared plus equals 2 squared. So r squared plus 2r squared equals 4. 3r squared equals 4. R squared equals 4 over 3. R equals 2 over root 3. And that's the radius of the small circle. Now we need to find the perimeter of the grey semicircle. So we know the radius, so to find the perimeter it's pretty straightforward. We just do, well, it's 2r to get the diameter along here. And then we need to get half of the radius, half of the circumference of the circle. So that's going to be 2 pi r. So obviously the 2 cancels with the half, so you end up with 2 lots of 2 over root 3 plus pi lots of 2 over root 3. And that is the perimeter of our semicircle. So that's 4 over root 3 plus 2 pi over root 3, 2 pi plus 4 over root 3. And if you so wish, you can factorize out the 2 over root 3, pi over 2, and you can also rationalize the denominator to get 2 root 3 over 3 pi plus 2. Next question. Question 10. The diagram below shows the triangle ABC. AC equals x, BC equals 2y, and BAC is 60 degrees. They're shown on the diagram. That's incorrect. That's meant to be 4y. BC is 4y. And so, given that the length of AB is 3y, so we might as well write that into the diagram. So that's 3y. Show that x equals 3 plus root 37 over y, root 37 over 2y. Okay, so we're going to use the cosine rule because we've got 3 sides and 1 angle. So we've got 4y squared equals b squared, which is, we'll select that as x, plus c squared minus 2bc over cosine a, which is that. So cosine 60 is half, so that cancels with the 2. So we've got 16y squared equals x squared plus 9y squared minus 3xy. Now we're going to subtract that onto the other side. So we get x squared minus 3xy, and then we'll subtract that, so that makes minus 7y squared equals 0. So x equals minus b plus or minus the square root of b squared, which is that squared, which is 4y squared, minus 4. A is 1 times c is minus 7, all over 2a. A is 1, so that don't count. So we end up with 3y plus or minus the square root, so 9 plus 27y squared is 30, so 9 plus 28 is 37y squared, all over 2. Now we can factorize out the y, because that y squared there can be taken out, so we've got 3y plus or minus root 37 over 2 lots of y. And that there is our answer. It's a show that question, so we don't need to put it in there. The diagram shows two rectangles. The area of the grey rectangle is 1/3 the area of the large rectangle. The angle between the bottom of the large rectangle and the dotted line is 60 degrees. Find x in terms of w. Okay, so we need to find x in terms of w, and we know that this is 1/3 of the full thing. So we're going to use SOHCAHTOA, because we know this is 30 degrees, so this is going to be tan, so we know tan 30 degrees equals opposite, which is this, so we'll call this O, opposite over hypotenuse, sorry, opposite over adjacent, which is W, so O equals W tan 30, and if you know your exact trig values, tan 30 is root 3 over 3. So this, or actually let's just leave it as a, just to make it nice and neat, let's just leave it as unrationalized, so we'll do W over root 3. So we know that now. We can work out this, so this here is 60 degrees, this is 90, which makes this 30 degrees. Okay, so let's work out this length here. We would use cosine. Cosine, so that's going to be cosine 30 degrees is equal to adjacent, which is x, over hypotenuse, h. So h equals x over cosine 30. Cosine 30 is root 3 over 2, so x over root 3 over 2. So it's 2x over root 3. So we'll put that in. 2x over root 3. So that's that length there. Now, because it's a rectangle, we know that that's also that length there. Now, we might as well use this one here, because this is going to be a 90-degree angle, to work out this length here. So that would be opposite and adjacent, so we're going to use tan again. So tan 60 degrees equals opposite, which is 2x over root 3, over the adjacent, which we'll call A. So adjacent must equal 2x over root 3 over tan 60, which if you know your exact trig values, it's root 3. So that's 2x over 3, because you divide by root 3 twice, you're dividing by 3. So this adjacent side is 2x over 3. Okay, so if we find this side here using these two, let's use the, actually we didn't need to find that one, because we could just find this is hypotenuse and this is adjacent, so we use cosine, that's 30 degrees, and that equals the adjacent, which is the W, over the hypotenuse, which is what we're trying to find. So the hypotenuse is W over cosine 30, which is w over root 3 over 2, which is 2w over root 3. So that's 2w over root 3. Okay, so this length in here must be 2w over root 3. Subtract this length here, because that's the whole thing, subtract this one, 2x over 3. We did actually need this because now we can work out the area of the full thing and the area of this one using all of these lengths that we've worked out. So we know that 2x over root 3, so 2x over root 3 times by this here, 2w over root 3, 2w over root 3 minus 2x over 3 is equal to 1/3 of the full thing. So it's equal to 1/3 of w times x plus w over root 3. So that's x plus w over root 3 times w. Okay, so now we can expand that all out and it should give us x in terms of w, sorry. So when we expand it out, we get 4xw over 3 minus 4x squared over 3 root 3 equals x. It's going to be x root 3 over root 3 plus w, and then that's all going to times by w over 3. Okay, so what we can do is we can multiply everything by root 3 or 3 root 3, so we get 4 root 3 xw minus 4x squared equals, and then if we multiply this by 3 root 3, we just get rid of these bottom ones here, we get w squared plus wx root 3. Subtract the wx root 3 from both sides, so we get 3 root 3 xw minus 4x squared equals w squared, because we've subtracted that from that. And now we need to find x in terms of w, so we need to make x the subject. Okay, so 4x squared, so I add that onto the other side, minus 3 root 3 wx plus w squared equals 0. It's a quadratic equation, so we can use the quadratic formula. X equals minus b plus or minus square root of b squared, which is going to be 9 times 3 is 27, so minus b, 27, w squared minus 4ac, 4w squared, all over 2a. So we get 3 root 3w plus or minus the square root of, so that's 27 minus 16 w, so that's going to be 27 minus 16 is 11w, root 11w, and all over 8. So x equals 3 root 3 plus or minus root 11 over 8 lots of w. Now, considering, well, if we try and make x equal to 0, or sorry, x equal negative, by using the negative here, you can never actually make x negative because this is root 27 minus root 11, which is positive still. So it can still take either of these values. So there are really two solutions for x in terms of w. Bob the Builder is making a sign for each house number on his street. He creates the digits separately, then fits them together on a plate to fix to every front door on his street, starting from the house number 1 and ending at house number n, where n is a 2-digit number. Before fitting the digits to a plate, Bob places all the digits into a large bag. Given that the probability of Bob randomly pulling a 7 out of the bag is 2 over 27, find all possible values of n. Now, it's worth noting here that the house number 1 is not 0, 1, it's just 1. Okay, so he doesn't make the 0 digits for the individuals. Now, to work this one out, you're going to have to use a little bit of trial and error, a little bit of working, just a little bit of problem solving skills. So if we start with 1, 2, 3, okay, so we need to, this probability here is equal to the number of 7s in his bag over the total number of digits in his bag. So if we keep track of n, and then the number of 7s, and then the number of digits in his bag, then P is just the 7s over the digits, and as long as that is equal to 2 over 27, that's the solution for n. So let's see what happens. So if we start with 1, there's no 7s. There's 1 digit now, and then 2, there's 2 digits, and then all the way up to, if we go all the way up to 10, then you'll find a total of 1 7 in here, because there's a 7 there. And after 10 digits, there will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 plus the 1 for the 1 there, so there'll be 10 digits. Sorry, not 10, 11 digits there. So if we do probability 1 over 11, 1 over 11 is approximately 0.091, which is greater than 0.074, which is roughly 2 over 27. So 2 over 27 is approximately 0.074. So that's greater than 2 over 27. So the reason that we're using greater than and less than is because when there's a sign change, that indicates that at some point they were equal to each other. That indicates that there was a solution that we missed in between there. So if we keep going with this, so we get to the 20s, there's another 7 because there's 17, and then we've got another 10 numbers, but each of those numbers have 2 digits in, so that's another 20. So we get 31 digits. So 2 over 31 is around 0.065, which is less than 0.074. That indicates, because there was a sign change, that there is a solution in here somewhere. So we'll say, we'll keep that in mind, okay? Solution in here. Okay, so we'll keep going. Now we get to the 30s, and there's another 7 because there's 27, and then another 50, and that gives us 0.059. So there's no sign change there, so there's probably no solution, very likely no solution in here, so we'll leave that one. And then 40s, so there's another 7. Actually, let's skip. So we keep going with this. Okay, what ends up happening is because we're not reaching, because these keep dropping now, these values here, we're never going to get above 0.074 again until we reach the 70s, because when we reach the 70s, we get another 7 each time round, each other number we get another 70. So by this point, we get 139 digits in total, because we keep adding 20 each time. And 8 over 139 is around 0.0576, which is still less than 0.071, so there was 0.74, which is no sign change, so no solutions in here. But if we keep going, and we get to 80, now watch what happens. Well, because each of these had a 7 in, that's 10 more 7s, and there's going to be 20 more digits, so that's 151, which equals 0.0113, which is greater than 0.07, which indicates there was a solution in here somewhere. So we've got 2 solutions so far. Okay, we keep going to 90, and then 99, because it's a 2-digit number, so it can't go any further. So at 90, there's another 7, and then another 7, and then there's 171 digits, and then 191 minus 2, 189 digits. So there's 0.0106, which is greater than 0.074, and then there's 0.102, which is still greater than 0.074. So there's no solution in this upper bit here, but there are 2 solutions here and here. So we need to find these 2 solutions. Now, notice we need to get to 2 over 27. This is 2 over 31. If we go back to 19, that's 2 less digits, so we've got 2 over 29, right, but we haven't lost a 7. And if we go back to 18, that's 2 less digits, and we get 2 over 27, which is what we're looking for. So that is a solution. So there's n, there's our probability. So in here, our solution was n equals 18. So that is our solution. Okay, there's one solution. Now the second solution, to find it, we're going to look at which one's closest. It looks to be this one here. So we'll start at 70. Oh, I've made a mistake here. That's 131, sorry. So starting at 131. So 131, add another number. We've got 9, because that's another 7 from the 71. So this is n is 71. We get 9 over 133. And so I'm expecting that this is going to be 135. So if we divide both sides by 5, then we get 2 over 27. So that is our solution, n equals 72. So we've got two solutions, n equals 18 and n equals 72. So n equals 18 and 72. Question 13. The number x satisfies the equation x to the x to the x equals root 2 over 2 to the power of 2 root 2. Find the value of root x. If it couldn't be more useless, yes, this is very, very pure maths. It's very abstract, and there is absolutely no use for this whatsoever other than to test your mathematics ability. So, it might help you to use a pencil for this one, because it's going to be a lot of trial and error. So first of all, I'm going to turn this into a power tower with 3 on it. So, well, okay. So let's do 2 root 2, and we could turn this into a power tower, and we get, so 2 root 2 equals 1 over root 2, which is 2 to the minus a half. So we could get 2 to the minus a half to the power of 2 root 2, which is a power tower. But I want to take this all into integers. So instead of doing that, what I'm going to do is I'm going to do root 2 over 2 squared, and then I'm going to put it to the power of root 2. And the reason I'm doing that is because root 2 over 2 squared gets rid of the surds here. So that's 2 over 4, which is 1/2. It'll be helpful if you use a pencil for this, because you'll need to rub out a lot. And then to the power of root 2, which is 1/2 to the power of 2 to the power of 1/2, which is indeed a power tower with orders free, and there's no surds in it. The reason why we don't want surds is because raising to a power of surd gets very confusing and difficult to see what's going on. So we're going to raise it to the power of rational numbers, and annoyingly it's very, very close to being the same, but it's not quite the same. It's 1/2 to the 2 to the 1/2, not 1/2 to the 1/2 to the 1/2. So a way of thinking about it is, okay, let's start at the top and try to make them the same. Okay? So let's look at 2 to the 1/2 first of all. Alright? If we try and make 2 to the 1/2 the same, well, how can we make those two the same? Well, if we multiply the 1/2 by 1, but instead of using 1 we say 4 1/4, never mind, but instead of doing that we multiply by 2 and 1/2, so that's just 1, then you get 2 to the power of 1/4, and then to the power of 2, which is 4 to the 1/4. Okay, so you can make you can basically prove that 2 to the power of 1/2 is 4 to the power of 1/4. Now, if we put that into this problem here, we get root 2 over 2 to the 2 root 2 equals 1/2 to the power of 4 to the power of 1/4. Again, not the same. Now they're all completely different from each other. But we haven't yet tried to make this into the same here. Now, the very, very observant and very, very mathematical genius of you might have noticed exactly where we can merge these two and make them the same. how we're going to do this is we're going to use another multiplier. So we're going to use 1/2. Now, think about it this way. We need to turn this into a 4. So the only way we're going to do that is by getting a 2. But the 2 is raised to the power of a quarter. So we don't want a 2 here, because if we have a 2 here and we raise it to the power of a quarter, we're actually getting 2 to the a quarter in here. So we want something, we'll call it y, to the power of 1/4 is equal to 2. And that something is 16, okay, because we raise it to the 4th power. So we want 16 here. That way when we raise it to the 4th power, like it is being raised up here, then we get 2, which we can then use to power this and turn it into a 4. So lots to think about going on at the same time, but just remember, if we make a 2 here, we can't just put that down there and make it 1/4, because there's a quarter up here that we've got to think about. So we've got to think about making something that makes a quarter up here, so that we can then use that to power this into a 1/4. So we've got to make this 16. How do we make this 16? Well, we can times this by 4. So we times this by 4. So we get 4 times 4 gives us 16. But then we also have to balance it with a quarter just to make it the same as this 4 here. And then 1/4 up here. Okay? So that is the same as that, because that is just 1. So what we now do is we can get the 16 that we wanted. There's the 16. And then we've got our quarter that we also wanted, to the power of a quarter. Now, just dealing with the middle exponent, this one here, notice that this 16 to the 1/4 gives us 2. And then we multiply by 1/4 to the 1/4. Now, using the power laws, a to the m n equals a to the m to the n. So we can just do a half. So using that on this one, just do a half to the 2 to the 1/4 to the 1/4, which makes 1/4 to the 1/4 to the 1/4. So the only way really you work this out is a little bit of trial and error, a little bit of playing around, and also thinking in advance about how this 1/4 up here is going to interact with this, which is going to interact with the bottom one, so that you don't just stick 2's in and try and make it, you know, you've got to think about this, you've got to plan it out basically. But that is equal to x to the x to the x. Therefore, x equals 1/4. We need to find the value of root x, therefore root x equals 1/2. Okay, now yeah, technically it could be plus or minus 1/2 in this situation, so we just put plus or minus 1/2. Question 14. A 5x5 grid contains coins. The coins are arranged such that the total number of coins in each row and column equals 1. Find the total number of possible arrangement of coins. Okay, so what a lot of people think with this question is they start with this grid and they think, well, okay, you've got 1 here, 1 here, 1 here, 1 here. The sum of the rows and the columns are all equal to 1. So surely the only other solution would be if you've got coins here, 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 and here. But then you also realise there's another solution. You could also have coins here, 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 and here. Right? 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. The only way to really solve this question is to think about, right, okay, if I want to fill in a grid 5x5 where there's only 1 in each row and 1 in each column, what I'll have to do is I'll have to go, okay, left to right, filling in boxes in each row, but to make sure that each of the rows add up to 1, I can only choose one box to be the same per row. So I can choose only one box of each of these per row. So what I mean by that is if I chose this one and then this one, then I cannot choose this one again for the coin, because otherwise that would make that 2. Okay, so I have to go with a different one that I haven't chosen before, and a different one that I haven't chosen before, and then a different one that I haven't chosen before. So I have to basically select different rows each time. So the question is, how many different ways can I select different rows each time? Okay, and well, the number of ways is found by by using a bit of common sense. If you look at this grid again, start with the left and think, okay, how many possible options do I have? You have 5. Okay, select one option. Now how many possible options do I have? Well, I've already selected that one, I've already filled that with 1, so I can't use this row again. So for this column, I've only got 4 options. I could go here, for example. So I've got 4 options there. Now, how many options do I have? Well, I can't use this one or this one because that would make the sums equal to 2, so I've only got 3 options. I'll go with this one. Next one, can't use these rows or this row, so I've got just 2 options. And then finally, well, I can't use any of these 4 rows, so I haven't really got any other option. I've just got this one. Okay, so the final answer is 5 times 4 times 3 times 2 times 1, which is 20 times 6, which is 120. So how you score this is basically you get 1 mark for each concept, okay? So you don't have to actually write down the explanation. As long as you get the 120, then that is your 4 answer marks. You're complete, okay? Whatever way you use to get that number, that is the answer that gets you 4 marks. But if you get a wrong answer, but you almost got it right, but you explained how you got there, then you can score the method marks. Okay. That is the last question. Complete. Paper 3. Done now.